Good morning to everybody. I think that it's time for us to continue this summit with the second day presentations. I hope you had a nice evening in Warsaw and you relaxed, and today we are ready to continue with the same intensities with which we worked yesterday. I think that that was really amazing day because all of us here have the same goals, the same interests, the same problems, and it was very helpful to exchange ideas to try to find mitigation strategies as much as that is possible. But this which is important is that we are learning from the good practices. Today, we are going to continue, I hope, with the same spirit, but today we have something which we didn't have yesterday. We were talking about deployment of technologies using equipment which is produced by leading companies situated not in our region, Central and East Europe, even not in our continent. Today we shall have the unique advantage to hear about one innovative development here in Warsaw, in Poland, on solid oxide, electrolyzed and reversing cells, which is really innovative. Those are ceramic cells which work at high temperatures, and they are extremely convenient for using coupling with different chemical processes, which means for industrial applications as ammonia production, because they use the exhaust heat, and because in this way their capacity goes to above 80%, and for 1 kilogram of hydrogen you may go down to 40 kilowatts. But we shall hear later on this topic. Now I would like to start with one very exciting title, Making Hydrogen Economy a Reality, something for which we are dreaming. And I would like to give the floor to Thomas Silla, who is head of project management, Green Energy Park Global. Please, the floor is yours.
Good morning, everyone. I'm Thomas Silla from Green Energy Park. And this morning in the first session, we will really talk about making the hydrogen economy a reality. We will talk about, on the examples of our gigaparks in Brazil, in Kruk, how important it is to think in a large-scale hydrogen production, to have global corporations and international partnership, that we reduce the emissions with a target to 2050 to net zero, and how important it is to have an efficient infrastructure. But first of all, I will tell you something about the Green Energy Park. It's an initiative of several companies which have most experience in the gas industry. Since over 40 years, one of the company is in the LNG business, and others are in the leadership of hydrogen relationships. These are our executive board, and these are also the founders of the Green Energy Park. Here we have Bart, our CEO. He was a former executive director of the Clean Hydrogen Partnership of the European Commission. Then we have Tobias, our CTO, he and his family owns the TGE Gas Engineering GmbH, which is a world-leading company in EPC contracting of storing and handling liquefied gases. And also he's owner, the family is owner of Gasfin Development. This is a company which connects right now the FSRUs in Germany and will operate them. Then we have Minaugas Zakaras. It's our COO, is the leader and the owner of the MT Group, EPC contractor from Lithuania, building right now the refueling station, the first refueling station of hydrogen in the port of Klaipėda. And last but not least, we've got Mario, our CFO. The things the other guys think about needs to be paid, and this is his duty. He's a former merger and acquisition advisor of Morgan Stanley, and also is the founder of Exogen Hydrogen Solutions. You see, these are our offices we are most probably placed in Europe. I'm personally placed here in Bonn in the engineering department and the project management department. Our headquarters is in Rotterdam, and you see where we are going. For the next slides, our gigaparks and where we produce the hydrogen, they're not in Europe. We will start the producing of hydrogen and green ammonia in Brazil. Also, we are owner of a land where we talk about later in Krk in Croatia, which will be a hub for the green ammonia. This is what we are planning. We like to control the entire value chain from upstream to midstream and to downstream. This means we will produce the green ammonia in Brazil, distributed to our hub, most probably to our hub in Krk, but also we are in discussion with other ports in Europe. And also, and this is where we are coming from, we are already in discussions with off-takers and signing agreements with them for the green ammonia. And the thing is, if you understand this entire value chain from the green electron to the green molecule, so you can really contribute to the hydrogen economy. This slide shows us the importance of those large-scale hydrogen production projects. You see, the green ammonia will become more and more important in the next years. And if you see this, until 25, we have to install 6,000 gigawatts of electrolyzer capacity. Other figures are much higher. They are talking about 11,000 gigawatts of electrolyzer capacity. And if you have in mind then our project, which is in the end phase, only if we talk about 11,000 gigawatts, 11 gigawatts, and which is already a very big, €1 billion project, then it's very, very small in this context. Let's jump to Brazil. This is where we will produce our hydrogen and our ammonia. Why did we that? We, or my colleagues, visit before we were founding the Green Energy Park with a lot of countries in the world. And there was no other country than Brazil where they found the lowest levelized cost of hydrogen. This is also in line with the Bloomberg report of 2021. Besides these low costs, there are other advantages in the area we will see later. For example, in the northeast of Brazil, there is already a green grid with more than 90% of renewable energy based on hydropower, on solar and wind power. With these conditions we found already there, we are fulfilling already the RED III requirements from the Europe Commission. These are our 3 projects in Brazil we develop right now. They're in the northeast of Brazil. There's 1 gigapark we are developing in Maranhão. This will be a gigapark where we produce the hydrogen for a power-to-X application later on, which is from Vale. It's a DRI process. The other 2 gigaparks, Sergipe and Piauí, there we will produce the green ammonia as a vector and transport it to Europe and other destinations of the globe. Most probably it's Asia and the Middle East. The thing is, in this area, and this is an advantage why we looked in this area of Brazil. That's their location. It's an easy transport to the destinations in Europe. The other thing is, we found there good operating conditions for the plants, and what's very important, because we're going with the electrolyzers to produce the hydrogen, we found freshwater resources there and don't need to desalinate the water from the sea. This is how our concept, how we will build the plant. We will find everywhere on the destination, on the gigaparks I just showed, we will find the green grid, we have the freshwater resource, and on a modular-based concept, we build our hydrogen plants. Then, after the hydrogen plants, we connect power-to-X applications, as I said, like this HBI production of Vale, or even for the projects in Piauí and Sergipe, we have an ammonia production. And then even the bulk material or the liquefied gases will be shipped via export terminals to and bunker facilities to their destinations, Europe and locally. All of them should be, or it is our idea, this will all be modularized, even these facilities, which needs to be adapted to the local conditions. Here we see some examples of these modules. We have our modules. This is one production train we see here. These production trains have a capacity of 300 megawatt of electrolyzer capacity, and also with the equivalent of the ammonia and air separation units. Why we choose this? You may ask the ammonia synthesis, you can build bigger plants. This is already a common standard in the world. There are different facts why we chose this 300 megawatts. On the one hand, we would like to modularize everything, and then you come to a border where you can handle the modules and ship the modules. And the most important thing is it's a financial and an investment issue, because we are not only producing the hydrogen or ammonia in the states of Piauí or Sergipe. We have also clients that are right now interested to own their own production train of 300 or 300 megawatt trains. And we will operate as Green Energy Park later on with partners such a terminal and infrastructure with those production lines in it. And as I said, these terminal infrastructure, I said that before, should be also as uniform as possible, just to adapt to the local requirements. These are our trading routes, trading corridors we are looking at. We are centering our trading activities or shipping activities around our hubs here in Brazil, our gigaparks, and also for the local distribution here in Croatia, to the Middle East, Asia areas. These trading corridors are already in line with the green shipping corridors of the Global Gateway initiative. From Brazil, we are shipping roughly 55% of our production, which is roughly 7 million tons per year of green ammonia to Europe. 20% we will send to Middle East Asia, and 25% will stay in Brazil. You know that Brazil is one of the biggest importer of ammonia in the last years. Why we choose these same corridors as the Global Gateway? Since last November, our projects are flagship projects of the Global Gateway, and we were already mentioned by Ursula von der Leyen a year before, in November 2023, that the Green Energy Park will be a part of the Global Gateway initiative and also will help to the hydrogen value chain in Brazil. We normally have a speech from Ursula von der Leyen here also, but we will skip it because due of the time. Just left 5 minutes and we're not at the end. So let's come to our gigaparks. This is, for example, is a picture of our gigapark in Piauí. You see the ZPE zone. We are in the free trading zone placed there. At the moment, we are in FID and detail engineering phase. We are focusing on the engineering. We are doing the concept study. We are working on studies for electrolyzers, our pre-certification for the hydrogen, as well as the environmental assessment. In this year, on the COP30, we would like to have an early investment decision, also announced with Ursula von der Leyen and President Lula. And by beginning 26, we would like to have our final investment decision based on a front-end engineering design and also a basic design we'd like to have that we can immediately start by mid-end of that year with the construction on site. Here you see the location where we are in Piauí. And you see there are three dots which are very important. We have 7 kilometers far away. This is the freshwater source we may use and we can use. And then we have an already existing substation, the Argus substation, which will deliver 3 gigawatt already to our plant for the first phase. Our first phase is 1.8 gigawatt electrolyzer capacity. And 18 kilometers far away is the port of Luis Carrera, where this will be developed from our side as well, and then we ship from there the green ammonia to Europe and the other destinations. Let's go back to Europe. This is what I said in the beginning. In the North Adriatic Sea, we own a land area, which is really unique there. We will come to that point. In that area, this will serve in Krk. This will serve a hub in Croatia. We will deliver all our or most of our products to this hub, but also we are open to get from different areas in the world the green ammonia. This is also one point which is a mitigation of the project risk, that we can, if there is a disruption in any of these countries or in any sourcing, then we can go to other countries. Here you see the land plot in Krk. This is close to the airport in Omišalj, and you see the crude oil terminal, and here the small ship. This is the LNG FSRU of Croatia. It's already moored at our land. This is a land plot. It's a complete industrial area with two jetties with 8-meter depth, and here we have already 60-meter depth. It's a natural seaport, so we don't need to dig there, and there can then the big ammonia carriers arrive. From that hub, you will see that we will distribute our product to one of the biggest industrial areas in Europe, North Italy. Then we will also distribute it to Austria, Switzerland, and the south of Germany, then the Balkan states as well. And also, you see, and this is the picture here, the members of the North Adriatic Hydrogen Valley are also our off-takers. Here you see what will be in the future. The island will be connected to the local railway system. They will build a second bridge there for the railway. This will help then distribute the product locally, and also we are in discussion to connect two pipelines in Slovenia, Hungary, and Slovakia. Here you see, and this is very crucial. Here you see it's the Adria gas pipeline corridor, which is already permitted. We are discussing that we will be connected to this corridor as well. In the pipeline, you can also not only deliver the LNG, because it's not built yet. You can also, the pipeline is possible to carry also hydrogen. Another interesting discussion we have right now is with the North Sea Baltic connector. All the big ports on the North Sea means Amsterdam, Antwerp, and Rotterdam are connected there. And we are talking to the ports to deliver also our products, means the green ammonia from Green Energy Park to these destinations. This brings me to the end of my presentation. Thank you very much for listening. I hope you enjoyed it as much as I did by presenting. Thank you.
Thank you so much. Yes, something exciting, volumes which our imagination difficultly accepts, but we have to start thinking in this way. I'm sure there will be lots of questions, but we are limited on 2 or 3 questions, so please, the floor is yours. Yeah. The other port, the European port.
Thank you, Thomas, for presentation. You explain a lot about GAP project, and you said that probably the best place you choose POE or even Parnaibas because of good way to Europe, comfortable way.
Yeah.
But probably there are more reasons why you choose that one place. And first, my question will be about pricing, of course. Probably you choose it because of electricity and possibility to get water. Another one question, what the structure is GAP, Green Energy Park, to say structure? Only today we have 4 board members and nothing more, or there are some more big, important companies? And once more, one question is, how do you feel? Is it enough security to invest in Brazil? How you predict political changes or something like that? Or simply, what is relation gap with the POE government?
Okay, there are a lot of questions, and thank you for these interesting questions. If I remember right, for the beginning, with the price, we found that, okay, in Brazil, in Piauí, we found more advantages as only the location. As I said, it's the fresh water, it's a green grid. Also the requirements, as I said, the requirements for RED 3, we are already fulfilling with the local situation there. This means for our first phase, the energy is already existing there, but it's not unlocked right now. So no new power plants needs to be built. It's just to unlock this hydropower for our requirements. So at the moment, they have no, they can't unlock because there are no consumers there, and they're very happy that we are coming with our project and consume these extra power there. The second question, could you please help me again? What was it? The structure. Okay, Green Energy Park. This is okay. This is not only the board. We have, as you saw, we have already offices in Europe, also offices in Brazil. We are at the moment roughly 40 to 50 people, and growing further to fulfill the requirements we need for this concept study, for this assessment, that we come really to the early investment decision at the COP 30. So we are a bigger company. It's also, and also, as I said, we are supported by the already existing companies of Tobias and Minorgas to bring our initiative forward. And the last one was? Yeah. We are. Yeah, correct. We are already a partner of Investe Piauí, which is, the Investe Piauí is 100% government-owned company there. So we have, and today you will see it via LinkedIn, or it was yesterday. My colleagues, that's why Bart not here, they are signed an agreement with CEE and the ambassador of Austria for the global gateway in CEE, that this project will also be pushed to the global gateway. So we are very close, and this is very important in this country and also in Europe. We are very close to the politics to bring such a project forward.
Thank you. Thank you very much. A second short question. Yeah.
Hello, Karel Kuusk from Eesti Energia. What would be the price of hydrogen in Europe?
So, as you know, the price is really driven for the hydrogen is really driven by the energy price, and we have a very competitive energy price in Brazil. At the moment, we are talking about 30 euros per kilowatt hour, and we are calculated already that we are able to bring, because we are in discussions, for example, with Salzgitter and ThyssenKrupp Steel, we are able to bring the green hydrogen, very competitive to blue hydrogen, to a price of under 6 euros to the door of those companies, which is very competitive. The latest price I have in mind from Spain, they can produce the kilogram hydrogen for €5, but it's still in Spain. It's not shipped to some destinations in Europe. So we are very competitive, and also for the project with Vale, we made studies, and we are cheaper in producing these HBIs in Brazil with the green hydrogen and from Brazil, and ship the HBI to Europe. We are cheaper than this HBI will produced on the classic way, or even with blue hydrogen.
So it is €1 per kilogram more because of the transportation, if I could understand well your numbers.
Yeah,
5 in Spain, but
correct.
6 because you are transporting,
Yeah,
right?
correct. Roughly in that way,
Yeah.
but the transport is not the biggest issue. It's really the energy cost in the beginning. The energy costs in Europe, they are much higher. For example, I've got the energy cost in Canada, because we compared this as well, because they have more or less the same situation, that we would fulfill the RED III requirements as well, but they are 3 times higher in energy costs than we found in Brazil.
Well, thank you very much for this exciting presentation.
Thank you.
Yeah. Now we are going to one topic which is an issue for everybody, fire safety and standards in the context of hydrogen transport, given by Paweł Piotrowicz, member of the management board of Hydrogen Poland. Thank you.
Ladies and gentlemen, hello everyone. I'm glad to be here with you. I have 20 minutes to tell you about the fire safety on the context to hydrogen transport. However, I must emphasize that I'm only touching the subject. We have no time. After all, you know, hydrogen has been present in industry for almost 150 years. So we are quite capable to handle it. This doesn't change the fact that accidents do happen. I'm sorry, I should start by introducing myself. My name is Paweł Piotrowicz. I'm vice-president of the Hydrogen Poland Association and an expert at TIFSIT. As you can see, I have many other activities. However, I will not talk about myself here. Let's move on the topic of my speech. At the very beginning, I told you that we have known about hydrogen for a long time. We know what its properties are, and we can use them. Today we will talk about one of them. Hydrogen has a wide range in which it creates an explosive atmosphere, from 4.1 to 75% of hydrogen concentration in the air. A hydrogen mixture that fulfills the conditions of the explosive atmosphere is not enough. For the explosion and fire to occur, the ignition trigger must be met, also known as ignition triangle. The missing vertex of the triangle that I have not yet mentioned is the ignition source. Here you are a few such sources: flame, hot surface, electrical spark, static discharge. Let's look at some examples of such failures, disasters, accidents. We have a photo on the screen that was taken in Norway in 2019 on HRS. The cause of the failure and result explosion was a valve in the hydrogen storage tank. and it was the fault on the following the service procedures and the safety of the service personnel. In addition, most accidents to date have been accused by the lack of proper training and or failure to follow proper procedures by people working with hydrogen technology. Another example, the video, you can see the effect of electrostatic discharge and the explosive reaction of the hydrogen component. Obviously, someone forgot the basic safety procedures. It's hard to resist weeping when you spill something, but the hydrogen components, you shouldn't. There are procedures for that. The next photo shows the fire in the hydrogen trailer, or rather the final of this fire. It's likely this, that an emergency hydrogen drop was observed a moment earlier. The fire brigade reacted correctly by carrying the dam of water that cooled the area to prevent the fire from spreading. I will talk about guidelines a little bit later. Truck carrying hydrogen fuel explodes after crash. It is a title of the TV news report. The fact is that the accidents happened, but the hydrogen didn't explode. As a result of the deformation of one of the tanks, there was emergency release of hydrogen. During decompression, the hydrogen started to burn, and we hard observed it. I suspect that the structural elements were also burning, which why the flame is so clearly visible for us. The clickbait title of the news item is misleading, as you can see. The question I ask on the screen is a rhetorical question. Today, hydrogen is found probably every branch of the economy, therefore its use must be properly regulated for our safety. In Europe, there are many regulations related to hydrogen, both economic and legal, such as directives, and technical, such as harmonized standards. I have listed several dozen standards on the right, and these are just a few examples. Really, these are only examples. There are many, many more. So is market overregulated? This is a good question. In my opinion, new standards are needed to replace the old ones. Technology does not still stand. It evolves. For our safety, we need guidelines so that manufacturers know how to design and create new products and service safely. The world is not only in Europe. The sources of good standards are organizations from all over the world. I have put some of them on the screen. You probably very good know them. Europe is keen to use all sources, whether they are local, European, or from US, for example. Of course, I invite all interested parties in Poland who want to influence the standards to take an active part in technical committee for hydrogen technology and processes at the Polish Committee for Standardization. A very important part. When talking about new technologies in European market, we have mentioned the CE marking. It is extremely important. On the screen you can see 5 aspects of complete set of industrial equipment CE. Identify applicable directives. Determine which CE marking directives apply to your equipment. Common directives include the machinery directives, 42, low voltage directive 35, and for example electromagnetic capability EMC directive 30. Next one is compliance with standards. Ensure your equipment complies with related harmonized European standards, for example EN 60204, to identify potential hazards and implement measures that mitigate them. Technical risk assessment, very important. That is ISO 12100. Technical documentation, prepare comprehensive technical documentation, including design and manufacturer's details, risk assessment, test result, for example. And finally, declaration of conformity, stating that your equipment meets all applicable directives and standards. This document must include the manufacturer details and list of directives and standards, of course, legally binding signature. Now all that remains is affix the CE mark. Once all requirements are met, affix the CE mark must be in your equipment. This indicates that equipment complies with all relevant European directives. That is complicated, maybe a little, however, thanks this procedure, we can trust that the products with the CE mark is safe. Let's give me another example of how hydrogen tanks vessels are tested in detail. What acceptance and approval test do they have to pass before can be used safely? Of course, this is just example, and test may vary depending on the design, the material used, and the type of gas or liquid stored. This is what the relevant standards are for. These are not short or cheap tests. However, the tanks that are approved for use and then used in the cars or trains. Therefore, they are most safe. On the following slides, you can see how they are treated in automotive tests. I started to talk about this when I talked about safety standards. On the next few slides, I'm going to show you some examples. They come from publicity available sources or made by me. So I take liberty to showing them to you. On the screen you can see cross sections of the Toyota Mirai. I had the opportunity to visit Toyota factory near Jakarta, Indonesia. I took these photos there with the permission of the local management. As you look at this or other photos, I want you to notice that weight to hydrogen-related components are very good arranged. This is well-designed crumple zone everywhere, and additional sensors are located in several places. The pressure in the system is constantly monitored. Fuel cells vehicles are really, truly among of safeties of world's roads. Please note that the fuel cells cars are usually new constructions. So that the hydrogen system is properly protected. On the screen you can see the location of the vessel under the passenger seats and hydrogen supply to the fuel cell. On the right you can see the chassis and how it's protected by a special plate so that none of installation are damaged when overcoming obstacles on the roads. Here is a short film showing what happens when a hydrogen car hits an obstacle. Of course, there's our laboratory test. You can see how the hydrogen tanks behave. The system is sealed. You have to remember that every car is different and the tanks are in different places. Hydrogen tanks are designed to remain sealed in the event of collision to prevent the creation of the explosive atmosphere. However, there are situations where other vehicle systems, such as batteries, catch fire or the hydrogen tank is physically deformed. In such cases, the TPRD valve plays a key role as it is designed to release hydrogen from the affected tank in the controlled manner. There are not many real examples of such accidents. The few that exist have been used in the laboratories for testing purposes. The TPRD valves reacts when the temperature of the immediate environment exceeds 110 degrees Celsius and when the pressure in the monitored system changed abruptly. In the case of cars, TPRD valves are installed under the vehicle. The diagram shows how an explosive atmosphere is created depending on the angle of the TPRD valve. Obviously, it is installed at a certain angle to ensure the safety of anyone who may still be inside the vehicle. A laboratory example on the right shows the TPRD valve facing straight down. We have hydrogen ignition and the effect of this fire on surrounding vehicles. I have two messages for you. Firstly, the hydrogen will only be released in the extremely serious accidents and will be safe for the passengers because the TPRD valve will safely direct it outside the vehicles. Secondly, that means that the fire brigade should be properly trained to carry out rescue operation away from the danger zone of the emergency hydrogen release. That is very interesting. Well, what would happen if we removed such TPRD valve from the vehicle? What would happen when we use the hydrogen system to explode? This question was answered by experiment carried out in one of the technical laboratories. The screen shows the effect of the explosion. Please note that some parts of car, weighing over 20 kilos, traveled over 55 meters. That is why I have said before and will say again that TPRD valve and the emergency hydrogen release are not bad thing. It is safely measured to protect us from far worse consequences of a hydrogen tank explosion. I will say that the hydrogen vehicles are some of the safest vehicles on our roads. Here is very short. I mentioned the fire brigade procedures. This is one of the better I think that is the best procedures and guidelines in Europe. And I have the last one slide. A week ago, I was in Cape Canaveral, Florida. I wanted to share some insights with you about hydrogen and hydrogen technologies. I had the opportunity to discuss with engineers from NASA, but that is topic from another lecture. Hydrogen has made, is making, and will make a great contribution in the space exploration. You can see on the screen how many functions it performs and can perform. I assure you that it is not all. It is most abundant element in the universe. And we already know a great deal about and can use it safely. That is all from me. That short meeting, I would be happy to talk with you during the break. I'm sorry, I must go away for 20 minutes. In the break, I'm ready to answer for your question. I have a very important meeting now. I'm sorry. In 15 minutes, I'm come back.
Thank you very much. So, no questions? One question?
One question.
Yeah, please, quickly. I do not see a hand.
I'm
have,
available on the break. I'm here.
may I ask something? What to do with the local authorities which do not understand that hydrogen is not working horizontally but vertically and increasing the distances in comparison with natural gas? How to explain them that that's not the way?
All is in the norms. That's a very short answer, but the laboratory working on hydrogen science 100 years. We know what is the hydrogen, what can do hydrogen, and when you want to know about the distance, safety distance, it's very depend on this hydrogen is in gas, liquid, or ammonia, or methanol, or another cases.
Okay, well, thank you once more for this useful. Could you have one question more?
Mr. Pavel, most important meeting is here, so you have to stay with us.
I'm sorry.
Okay.
But you know,
yeah.
you show us a lot of standards, European Union, not European Union, Canadian, American, and so on and so on, hundreds of them. But if you're gonna install some electrolyzer in Poland, do you have your own, Polish standards, which you can apply?
I think that's the future for us. I work with the Polish Committee for Standardization in Poland, and we work to implement, for example, NFPA, ASME, is very good standards for secure, for be safe. Especially, I work for safely in these standards.
Well, once more, thank you, and good luck in your next meeting. We are continuing with hydrogen transport corridors, hydrogen and energy system resilience, given by Marcel Kehlor, expert hydrogen and resilience, German Energy Agency. Please. Sorry for the pronunciation of your family name.
It's totally fine. I get this a lot with my last name. My name is Marcel Keilhauer. So, yeah, good morning. I'm very glad to be here today. And Pavel is gone. I want to thank him for this great presentation because I didn't expect this to be so interesting. Where's the, oh, it's right here. Just a second. Okay. So, like I said, my name is Marcel Keilhauer from the German Energy Agency. For those of you who don't know who we are or what we do, so we are an in-house agency for the German federal government, and we work very closely with the German Ministry for Economic Affairs and Climate Action. So I'm kind of in the unique position to connect both with the political decision makers and with the industry leaders. But the challenge is then to derive an optimal pathway for the future from these two perspectives. So I think we can all agree that there are many uncertainties about hydrogen's future in the European energy system, and we need to figure out some ways to convince and to communicate its benefits. And today I want to provide you with some food for thought about how hydrogen's role in the future of Europe can be, and how resilience, thinking about resilience, can actually help us a little bit. But what is resilience, and why am I talking about this? So there are, is this sound okay? I'm hearing a little bit. Okay. Can I turn this off somehow? Okay, good. So for resilience, there are some different definitions, but I think it's most commonly used to say that it's the ability of a system to react to various circumstances, to challenges, and to recover from adversity. So basically, the less a system is affected by changing conditions, the more resilient, the more resistant it actually is. So this means for our energy system that it needs to be able to cope with hazardous events or trends, maintain its essential functions, and to adapt, learn, and transform. And when we are focusing on resilience, I think it can help us in two ways, because it can help us to communicate the need for transition towards hydrogen, and it can guide us to create a stable system that is built on renewables and hydrogen. And I think right now we can actually use some resilience, because we seem to be in the age of I call it the poly crisis. Because I think every couple of weeks there's a new crisis before the last one is over, so we're just stacking crises atop another. And these are some headlines of the last 2 or 3 years. I think I don't have to elaborate further on this. So those current uncertainties are putting a tremendous strain on the European economies and our efforts to combat climate change. And we can see that the geopolitical tensions, they endanger our critical infrastructure. And as you know, our current system, built very much on the use of natural gas, is not very resilient. But we don't have to just look at those events, like those so-called black swan events. We can also just look at how our current system-wide transformation to move Europe away from this carbon-centric, from being carbon-centric to carbon neutral and carbon-free, is also putting a strain on resilience, because the European electricity transmission system expansion is suffering many delays, and the days with negative prices on the day-ahead markets are increasing. I brought with you the numbers from 2023. The ones from 2024, they are even worse. So, for example, in Germany, there have been 10 terawatt hours of renewables been curtailed in 2023, and we need solutions for this. And I think that hydrogen can actually provide some solutions with increased flexibility in the system, because we can use flexible electricity consumers to offset temporary grid imbalances. So electrolyzers, for example, they can adapt their production to the availability of renewable energy, and hydrogen fuel power plants can be used to respond to unexpected high demand of electricity. For this, Germany has actually a power plant strategy that envisions the repurposing of natural gas power plants to hydrogen power plants. I think the total was 7 gigawatts by the end of 2030. There was actually a corresponding law, secondary legislation, that wasn't passed, so we have to wait for the new administration and see how this goes. But it's something that has to come. We just need this kind of flexibility, and for this we also need storage. because we need some hydrogen storage to build up resilience buffers. And hydrogen this way can be used as a seasonal and long-term storage solution, and it's a way to compensate also for missing imports from third countries. But mostly storage is important to serve the demand of the hydrogen fuel power plants. On the left you can see the projected seasonal fluctuations for Germany in 2045, and you can see that electricity production is way higher in the summer, spring and autumn, and lower in the winter, renewable production I mean. And this is where hydrogen storage can play an important role, as the demand in the conversion sector is seasonal, and I went back. So we need abundant amounts of stored hydrogen to have actually a positive effect on system resilience. But this is kind of where the problems begin, because for this we need a European hydrogen network and transport corridors. Because when we look at those maps, on the left you can see that not every country has the right geological conditions to create large-scale hydrogen storage facilities. In the center you can see that there's a mismatch between production and demand in quite a few countries, so we need to balance those, ideally with a hydrogen network. And on the right you can see that even the demand is unevenly distributed, with high demand centers in Netherlands and Germany, but as well in Lithuania, Poland and Slovakia. So if you were to build a hydrogen network, reusing the existing gas networks, this could help us to supply hydrogen evenly across Europe. And on a small scale, this is what Germany is planning with the core network. We talked about this yesterday, so I don't want to talk about this as much today. But there's one thing that wasn't mentioned yesterday, and that is that this network is actually designed to be bigger than demand is projected in 2032. So this is actually built with more capacities, so that if the demand is growing, we have some buffers to actually accommodate this capacity. And this network will be gradually integrated into a European hydrogen network. I think we had a few versions of this map already. But this is very important, because this will help us to connect the hydrogen production and demand in Europe, but also from third countries outside of Europe. And this is something that serves our system resilience, because if we shouldn't be relying just on one supplier, so we need to diversify our imports of hydrogen. And because the demand for hydrogen will grow rapidly after 2040, and this is something that just meeting the demand of Europe just by inner European production will be very difficult. And when we talk about deploying this infrastructure, this is very important, because this way we can actually stimulate the market. Germany has very high import demands. I mean, it's projected that Germany will need to import about 50–70% of its demand. And to provide the right framework, the federal government last year published the import strategy. And the aim is to establish closer cooperation between EU member states. And I don't know who it was yesterday, someone said that because of the right framework is missing, many actors are staying away from the market because there's not the right framework. And I think this is a good start, because it sends two signals. One, that there are market opportunities for exporters in Germany, and secondly, for the German industry, that there's going to be a reliable supply of hydrogen in the future. So Germany is trying here to be consistent in planning and accelerating this development of a diversified import infrastructure. And this will consist of the meshed German grid, pipelines, and also import terminals for import of hydrogen by sea, so mostly ammonia. And the core network and the import strategy, this is not just serving Germany, this is a framework for a more resilient hydrogen economy in Europe. Because enabling this transformation gives us the chance to plan this from the ground up, to monitor, to evaluate, and to see what works better for the whole system. And as Europe's current gas transmission network is about to become increasingly redundant because of the move towards hydrogen, we can repurpose parts of those networks to reduce the development costs. And where those pipelines actually already exist, reconverting them would be of minimal impact. And it's very important to have this kind of interconnected system, because if a system is interconnected, it is less affected by sudden disruptions. But this will only work when the network is roughly built around the same time. And you can see this is the, right now from the PCI transparency platform, you can see PCI projects. So this is a good start, but still this is not forming a complete network. And even the efforts from the European Hydrogen Backbone, it's just not enough, right, to serve for a future hydrogen ecosystem. And so I think we can agree that hydrogen will play an important role in Europe in the future, but it's just not clear to what extent and what the time frame actually will be. And for this is something that's very recently. I just want to show you this really quickly. This is the German System Development Strategy. This has been in the works for quite some time now, but it's the first time it's been released in English. It's actually 2 weeks ago it was released in English. And this is like a overall approach. And it's about designing future development under uncertainty. Because no longer there's like this sequence of decision, planning, implementation. It's like a cyclical process, especially with the uncertainties in hydrogen infrastructure. So the strategy is designed to be a learning and iterative process, and it's not a master plan. It's like a holistic way to look at the system and to provide a vision for the energy transition while looking at the whole system, so even including district heating, for example. And this is a good start because it forces us to take a look outside of the box, and because transformation is happening quite rapidly, and we need to take the whole system into consideration. And I think this is something, that's why system resilience is very important, because of all those changes we are making. We need to always think about how to create a stable energy system. And in light of the time, I'm trying to save some time so we can discuss this a little bit more. Yeah, so I think that in order to tackle the challenges that are posed by the current transformation, we need to think about how we can create a resilient system and how we can make this with the flexibility that hydrogen can provide us. So we need the energy storage for certain availability. It can be an energy source with diverse supply options, and coupled with the hydrogen network, we can have a constant energy source. And so this is why we need this European hydrogen network. And when you think about resilience, it's something I think we can communicate quite well. Because, I mean, maybe you've noticed, but the amount we're talking about how to solve climate change, I think this time seems to have passed, because everybody that is on board right now that already knows that we need to transform because we need to save, well, basically our future. Those people are already convinced, but there's still opposition. And I think when we use resilience, we can use this to communicate this to stakeholders and to governments who are still not clear about their scope in the future involvement in energy transition or even hydrogen. And it can also help us to create a system that will be more stable in the future. And this is why this is kind of a holistic approach, like well, not just a philosophical way of thinking about this, but there's actually some. I talked to representatives of the Finnish hydrogen cluster, and they actually started focusing on this topic as well. And they have a nice saying, and that is, hydrogen is freedom. I think that's something very, very fitting. So yeah, I'm very curious about what you think, and hope we can discuss this a little bit more. But for now, I will say thank you for your attention.
Thank you very much. Now, the lecture is open for discussions, for questions. We see one positive approach. For me, I didn't think enough in this direction, but really hydrogen ensures resilience. And we have to stress this when we explain politicians why additional reason for supporting hydrogen. Some questions from the audience? Yes, please.
Hello, I'm Emma. I have a question around the imports. Is Germany thinking about importing ammonia via sea or just via pipelines? And how does that fit in the priorities of the German hydrogen industry?
So you mean if it's importing the hydrogen via import terminals by sea?
Yes.
Yeah. We have some terminals planned in the North Sea, especially on Brunsbüttel and Stade, I think as well. Yeah, they are planned, and they're actually they're going to be repurposed LNG terminals. Yes, this is for 2045. I think it's 200 terawatt hours of hydrogen derivatives will have to be imported, and the bulk of this will be ammonia via terminals. Yep.
Somebody else? Well, could you say something more about this system development strategy, which, as you said, is a new document, and more about the relation with hydrogen and hydrogen corridors, if that is possible?
So this is I'm not the one who helped to work on this. The Energy Agency is having the I don't know how it's called. We are so the Energy Agency is the chair for this strategy, but I'm not part of the team that's working on this. What I can tell you is that this is kind of a way to integrate this whole transition into one document, because we talked yesterday about there are different strategies, roadmaps, and this is very complicated. So this is just trying to have like one single document where all this is integrated. So when you look at this document, you will see the core network, you will see the import strategy. This is all integrated, and not just for hydrogen, but also for the electrification, for district heating. So this is something that can try to, so like an overall strategy for the whole energy system across Germany. And I think this is something that we need also for Europe, because we need to work together on this. This is, if just one member state is developing a hydrogen economy or is moving towards increased electrification, this will just not work. We need to do this together. And I think what Germany has done is trying to be a little bit spearheading this process. But this is what is happening right now, and in the last 4 years, we're going to have elections on Sunday, and yes. This is going to be a very interesting process, I think. Yeah.
Thank you very much. We need such an approach, and maybe the other documents in the other countries should follow this approach, because hydrogen is part of the energy mix, and that is something which reminds me the SET plan, the European Energy Technology Strategic Plan, which combines all the new and clean technologies, show good direction. But I think that there was a question, or yeah, please.
Thank you so much, Rumiana Grozeva, Stara Zagora Regional Economic Development Agency, Bulgaria. You said that hydrogen is freedom. Very good. But I'm wondering, listening since yesterday and today morning about this import from Brazil. I like Brazil very, very much, really. And import from some other sources. What about this Europe to be more ambitious and to mobilize its own sources and resources to be independent in this field? And probably Germany will be lead in this one.
That's very good. First of all, I don't want to take credit for hydrogen's freedom. This only goes to the Finnish hydrogen cluster. They did a very great job, so I can't take credit for this, but I like to repeat it. You're totally right. I mean, Europe should be more ambitious in this, but there is, I don't think that the problem is really right now the industry, because the industry has some big ambitions, and I think we need to, because one aspect of resilience is actually local supply chains as well, so we need to develop our own technologies in Europe before importing them from somewhere else. But the willingness to do so on a political level in many administrations across Europe doesn't seem to be that high. So, and that's why I'm saying is that when we focus on resilience, we can maybe convince some administrations that are not really convinced about renewables, and they think this is some kind of, it's too progressive, it's too modern. No, we can frame this differently, because we need, because energy independence is something that is very important, and the world order that we had, I mean, with relying on American security, this seems to be over. So seems like Europe is on its own for the next few years, and I think we really need to think about how we want to deal with this, and we need to think about this like right now.
Thank you. And that is connected with the development of hydrogen in our Central and East European region, because if you compare it with the deployment in the more western part of Europe, you see that the difference is very big. So we have to be really more ambitious and to try to overcome the barriers coming from not enough knowledge and not enough political awareness. Thank you very much. It was an interesting discussion, a little bit further from the technologies, but now we are going back to the technologies. I just want to announce that we are going to miss one lecture, the lecture for eCube's hydrogen route, and we are jumping on the solid oxide electrolysis cells on the second lecture. We start with solid oxide cell technology, status of double-sized cell product development in hydrogen tech, given by Bartolomei Lis, Technology Director, Hydrogen Technologies. Please.
Good morning, everyone. I am Bartłomiej Lis, and I'm here to show you our way to develop the solid oxide fuel cell, but slightly different from our competitors, as you see on my presentation. As a hydrogen tech, we are a company located in southern Poland. It is a private company, so we have to decide how to spend our money, and we decide and we believe that solid oxide fuel cell is the future of hydrogen production, and also not only hydrogen but everything what is around the hydrogen. We are a rather young company. We start at 2018, and then we find the investor who also believe in hydrogen and especially in solid oxide fuel cell. And they gave us money to start development on our own. And then we acquired the money from Polish government through the National Center for Research and Development. And we start project for building 1 kilowatt micro CHP system. And the advantages of solid oxide technology is the efficiency, because it's the highest efficiency among all the fuel cell technology. The other thing is that there is no precious metal like platinum. It could operate in both directions as the fuel cell, as the electricity generator, but also can operate as the electrolyzer, or in reversible mode, as the same device could be used to produce electricity or hydrogen. Also, the purity of gases could be lower than for other fuel cell, especially carbon-containing materials like methane or carbon monoxide could be used as the fuel for our fuel cell. And in electrolysis mode, we can do a co-electrolysis of water and also carbon dioxide, or even pure carbon dioxide could be fed to device. And one of the most important thing is the temperature of operation. This kind of cell operate at temperature higher than 600 Celsius degree, so the speed of reaction is very high. And the difference between the typical solid oxide cell and our cell is that we have channels engraved inside the anode structure, and on both sides of this cell, the layer of electrolyte and cathode layer is printed, and we close hydrogen inside the structure. So there is easier to seal the system. And we also resign from interconnectors, because in classical form, like here, between the cell, you have to use so-called interconnectors, which distribute fuel on all surface of cathode or anode, and also which collects current and take it away from the cell. In our construction, as you see in the next slide, we do it in different way. If we compare the main three type of cells, we have planar cell, tubular, and our DF double-sided fuel cell. And we have a lot of advantages over our over different technology, because we can increase the pressure of the cell operation. It is easy to manufacture this cell because it is flat structure, so we can use typical method like screen printing, like tape casting. It is easy to do it in the gas-tight way, because the sealing area is rather small. It is we can heat up system fast, so we start from cool down from room temperature to operation temperature in very short time, like shorter than 5 hours. It is a rather short time for solid oxide technology. And cycling stability, thermal cycling stability is higher, because there is no problem with gas leakage in the system. And this is more in detail description of our cell. We have main central anode, which is covered with so-called electrochemical active layer, and then electrolyte, barrier materials, and current collectors. we use similar materials to the materials which are used in the by our competitors. So the material is the same, but the construction of the cell is different. So different in construction of the cell made or induce a different way to design the stack. And this is the simplification of our stack design. So in typical device, you have cell and big gasket around the channels, which are used to fed with air, with hydrogen. In our case, we have only small gasket, this yellow gasket, around the fuel channel. And that way, we improve the gas tightness of all the system. And of course, the power of one cell is too small, so we need to connect cell into the stack and then connect stack into system or cluster of the stack. And on this picture, I show the approximate power of our cell, which is around 10 watts, of stack, which is around 250 watts, and system, which is made of 4 stacks, so the power is around 1 kilowatts. And this is a solid oxide fuel cell mode. And another way to increase the power is to make cell bigger. And from last year, we start to produce 4 times bigger cells, like you see on the bottom. And that's way we start to build bigger stack. Of course, we still produce this small cell for our development, for process development, for material testing, and so on. And this cell, of course, it's operate, so we do the tests, a lot of tests, and as we assume, the increasing of the area led us to higher power, higher current from single cell, and based on that cell, we want to build a 100 kilowatt system, but it is only the plan for now, and the speed or the time of cell heating up, as you see here, the green line is typical ramp for the system heat up. We test our cell and stack with very steep heating, but it is only for stack. All system, which I'm showing here, start below 5 hours from cold to fully operational power. But it is only not only the cell and stack, it's a whole system which we built for project from National Center for Research and Development, and it is fully functional micro CHP system, which is equipped with not only with the heart, which is solid oxide stacks, but also with fuel afterburner, with heat recovery and storage for domestic water production, and for electric energy integration with the grid, because the system was equipped with DC-AC inverter and also with battery, which was used to store energy and also used to start the system. This is the computer visualization of project for final device, which was designed based on our knowledge and experience from this previous system integration. It is not fully, it is not finished product, it is fully functional product, but the next step is to design and build micro CHP system for domestic application. It is 1 kilowatt system in electricity. As I said, the solid oxide fuel cell and stack are reversible and fuel flexible. And we do some tests on the same stack, which operate with pure hydrogen, hydrogen mixed with nitrogen, with also with methane mixed with water, which operate in direct internal reforming mode. So this stack could operate as the fuel cell, and also it could be used as the electrolyzer. It was the same stack, only the BOP elements was changed. But we can design the system which could be fully reversible. And also we test the cell, let's say, because it was very small stack. It was only five cells, which was fitted with landfill gas. The gas was just slightly purified. It was not deep purification. It was the same gas which was used to supply to internal combustion engines. And we performed some tests. Of course, the performance of the stack was lower than fitted with hydrogen or pure methane with steam, but it was possible to directly operate on that gas. And as the result of our activity during the project from government, we obtain a lot of knowledge and, let's say, byproduct. And as the private-owned company, we have to start earning money, and we have some product for industry partner and for R&D activity. And there are two groups. One is the components and materials for cell production, like tape casting especially. And another part is technology, is some product to evaluate our technology, but we know how difficult is solid oxide fuel cell technology, and we see that there is no market just for cell, because our cells are different than most of the world. So we need to supply all the system to evaluate cell, stack, and also the system to evaluate another devices. But we try to make work easier for our partners. And the last part is our capability to do tests for solid oxide fuel cell and for fuel cell independent on the technology. We have a lot of facility in Krakow and also on the area of chemical company of Synthos Group. And we have a test station to evaluate stack. We have also the software knowledge and people to design hydrogen system. And I think the last part of my talk is the result of our discussion with partners and with our customers, what they want from solid oxide technology. And one thing is to increase the pressure of stack operation, because now it's very difficult to integrate stack into the system. And if we increase the pressure, it will be easier for electrolysis and also for generating mode, electricity generating mode, because higher pressure improve efficiency of the system. You can use smaller diameter of the pipes, and so on. We see also that there is no demand for small system, especially for soft solid oxide fuel cells. So we are focused now on design, development, and then building high power system with 100 kilowatts power. And the last thing is that we have to confirm that our stack could also operate on different fuel than we do before. And ammonia and methanol is especially interesting for us. And so, thank you very much for your attention.
Thank you very much. Really, solid oxide electrolyzers and cells are the next generation and the future, especially for industrial applications. Please, the floor is open for discussions. That is more different from the discussions which we had up to now. It's connected with new technology. Thank you.
Thank you. It was an interesting presentation. I'm Yuri from Eesti Energia. I have some questions. First is, how long does it take to ramp up the electrolyzer to its maximum power? And how long does it take to ramp up the fuel cell to its maximum power from cold start?
From cold start, because it depends.
Let's say from cold start, 0 kilowatt to maximum that you have.
It depends on the system complication, because if we have isolated stack, like now, it takes a second. But the response of the system, like because heat is generated in the system, and if there is no current flowing, or if you do not consume fuel, the heat is generated in different part of the system, or is not generated. So the response of the stack is very short, like minutes, but the response of the system is it could be very long. So there is no simple answer that it is 5 minutes or so.
Okay, thanks.
It is often better to ramp up the load of the stack or of the system.
Okay, but what about the efficiency? Let's say electrolyzer mode. You consume electricity to produce hydrogen. How big is the efficiency? Compared, we know regular electrolyzers are in range of 60 to 70%. Where does your product place in this?
It's not so easy, because the efficiency for solid oxide technology is defined on different bases. The most general is the ratio between the energy input and energy output, and for that it is let's say 60%.
And what about?
It also depends from the source of heat, because solid oxide electrolyzer can consume part of heat as the source of energy. So if you have spare heat from process and the source of steam, you can improve your efficiency. But if you have to produce all heat in the system and evaporate water, it's decrease your efficiency.
Okay, so these are all questions that can be answered after balance of plant is done, and you know your exact system configuration is what I gather from this. Okay, thank you.
Just to add that those types of electrolyzers are very useful when you couple them, as I said, with industrial process like ammonia production or refinery where you have the heat and then it goes to 80-85% but those are still experiments on development level. Maybe you have reached already TRL 7, 8. For such experiments, you do not use the advantage of solid oxide fuel cells.
Maybe to clarify why I asked it is because as energy producer who wants electrolyzer, I ask because it's important for us to know how long does it take when we need to consume electricity to switch on electrolyzer. Does it take 1 hour, 10 hours, and how long until we can start using hydrogen to produce electricity? What are the electrical efficiencies both ways? These are the questions me as an industry person is interested in. It's actionable information that would be good for future. Thanks.
We understand you. Yeah.
I have already.
Thank you.
Okay, Jure Petrovic from MESA. We have a lot of customers who have a lot of excess heat. So my question would be, how would you connect, for example, a stack of an electrolyzers to an exhaust of a rotary furnace, for example, in a cement plant? Because they have a lot of excess heat and they need a lot of energy, or maybe they could use the hydrogen actually produced from the excess heat and electricity to use them in the burners, in the furnace, so just to make the cycle complete.
Okay, the easiest way is to produce the steam from this heat.
So indirectly?
Yes.
Okay.
But if the heat quality, the temperature of the heat which you can consume is high enough to operate, to heat up the air which you supply to the stack, is also beneficial.
And they have a lot of exhaust gas that could be even 600 degrees or even more. So, yeah. Okay. So even directly, it's possible,
Yes,
just to clean the exhaust gas. Yeah.
Even to consume some heat to improve efficiency of water splitting, of electrolysis, because it's so high temperature.
Thank you.
There are very good demonstration projects, clean hydrogen joint undertaking using solid oxide fuel cells in a refinery in Rotterdam with Sunfire solid oxide electrolyzers. Also for production of kerosene, they use them, and when they make the coupling for ammonia also, then the efficiency increases with 30% about. So that's really a future, but every case should be optimized in respect to the heat. And then the efficiency increases.
Okay.
Maybe one question. As far as I could understand, your cell design is something like mirror.
Yes.
The two parts are mirrored with the anode. Do you decrease the number of interconnects in this way when you touch two anodes, one next to the other?
Let's say we eliminate interconnectors at all, but if you want to see, or anyone else want to see our cell, I have samples here, so after my speech or during the break, you are invited to see and to discuss.
Thank you so much. Thank you once more for this topic related to the future and developed in our region. Now we go to the second talk on the same topic, solid oxide electrolysis and reversible solid oxide cells, given by Professor Jakub Kupeski, who is the director of the Center for Hydrogen Technologies and head of Department of High Temperature Electrochemical Processes in the Institute of Power Engineering.
Good morning,
Please.
everyone. I really appreciate the previous presentation because it provided some theoretical background and also information about the low TRL level. I would be happy to answer questions. Is this presentation still loading? Okay, 48%. The question about the efficiency, I think it is very important to clearly say that we can compare it on two bases. First would be just to have electrolyzers in 3 different technologies with the same boundary conditions. Let's say greenfield, alkaline PEM, and solid oxide, 20 degrees incoming water, 20 degrees outgoing gases. And this would be the same reference for comparing 60%, 75%, 85%, or even 93% in solid oxide electrolyzers. But then when we add to the picture the steam, which can be used here as a resource for delivering extra energy, we are operating at 94, 95, 96, and in some cases it can look funny, but the efficiency, electrical efficiency will be almost 100% because so much of the energy is in the source of heat. And then there was a question related to the kilns. So we worked with various industries, with cement kilns, with refining plants, and with nuclear business, having a simulator of high temperature gas reactor. And actually, whenever the steam is available at more than 550 centigrades, which is like a fresh steam in the conventional cycle, it will add to the extremely high performance. And actually, I will present you some of the systems that we built in such a design. I think I should blame the fact that I have a video embedded in my presentation that is not loading, but then I will start without presentation. So I'm representing the Institute of Power Engineering, which is a national research institute, and most uniquely we are 400 people. Well, last year we operated in 50 countries, but we are 93% commercial. So even though we are researchers, we don't call ourselves scientists, we are engineers, researchers who are doing business. And in my presentation I will end with a kind of important message related to what is happening in terms of the technology, but I will also show some research highlights, and I like this presentation from Hydrogen Tech because it shows you how many developments and advances are necessary. And of course, whenever you want to improve technology, you can do two things. You can improve the performance with high cost, you can increase the durability with increase of cost, or you can just try to maneuver in between. And then, of course, there is a scale-up strategy. And a scale-up strategy is typically a nice solution when you have a state-of-the-art technology, which can become cheaper only when you just go to this mass-scale production. And this is our approach. So we have worked over years on solid oxide electrolyzers to be sure that, should I replace the file with something else or just connect my laptop? Okay. Yes. All right, so I will just jump to the next slides. So this is where we are based, Warsaw. You can see the landscape of the city. It's actually a city center that we are now at. In our activities, we have just numerous things, but hydrogen is just one-sixth of the institute. But I want to mention that we're operating the largest electrical labs. For instance, if you are based in Warsaw, you can see that there is a lab with 5 million volts, and this is what we do for the electrical grids. Actually, we are responsible for the development of those 1.3 million volt systems in Saudi Arabia, and you can see that those are the largest transformers in the world that are tested by us. We do various things. Destructive things, which are the most fun, but quite often we collaborate with companies, and for instance, Orlen strategy was presented at our headquarters. The Center for Hydrogen Technology has this focus on various aspects, as I mentioned. We are 62 people now, and it goes all the way from materials development, the design development, the process development, fabrication, advanced techniques, and eventually system design, construction, and operation with industrial partners. The value chain is pretty broad, but we see it from materials to systems, and the Power-to-X and the chemical processes are a key component because those are the solutions which build business cases, and we are about making money with the technology by the end of the day. I want to mention that this is done in relation to the Polish hydrogen strategy. Yesterday we had a nice talk, and Bartłomiej Kupiec was mentioning the hydrogen strategies across Europe and Central Eastern Europe. Poland has developed its strategy 3 years ago. We were in charge of that, and these days we are running the process with 250 stakeholders who are actually the signatories of the sectorial deal on hydrogen. And the sectorial deal has established several KPIs, hydrogen valleys, some initiatives, and a flagship project. And this, what I will present later on, belongs to these goals and those targets. Our technology is entirely solid oxide cell, which can be operated in several modes. I will get to that soon, but most importantly, it's our flagship product. It is entirely designed, built, and manufactured in Poland. It is our product of the future, which is kind of an excellence seal from the government. And within the Green Evo technology accelerator, it travels the world for various fairs and just to meet the customers across the world. It was also our product at the COP in Azerbaijan, Baku, last year. The cells that we produce are typically manufactured for research teams, the small ones, and we sell them across Poland and across the world. The big cells make our stacks. Here you can see our 5 kilowatt module, which comprises 90 cells, 11 by 11, and this is the building block for the systems that I will present later on. And of course, the solid oxide cells have the unique feature that they can be operated in actually 3 different modes. One would be the solid oxide electrolysis, either integrated thermally with the process or just a standalone container. And then it can be a fuel cell mode, which offers a unique advantages. We heard it in a previous presentation. I will not cover that in detail. And solid oxide cells can also do this at the same time. It can be one unit, which is an electrolyzer, operated interchangeably as a fuel cell. And it established something called a reversible system. So something like energy storage unit, but it can be system that is producing synthetic fuels, and it can go all the way from water and electricity through hydrogen, synthetic fuels, gases or liquid, ammonia, down to electricity and steam or heat, which means that it can have a versatile application, as I mentioned here, as either a prime mover in cogeneration or polygeneration, but it can also find an application in heavy-duty propulsion. But we are rather about stationary applications. And of course, the technology can be advanced. We're typically going to focus on the microstructures, on advanced materials, on the composite electrodes. We will try to escape from cobalt and critical raw materials whenever it is possible. Anesh is leading our activities on introducing copper instead of cobalt in the stack components. And of course, we are partnering with a number of organizations within European projects for advanced designs and fancy designs of electrodes. I like this presentation for Hydrogen Tech. We worked on those structured electrodes, but we terminated this activity 10 years ago. We focus on the planar cells. So in Poland, we now have a nice complement of 2 technologies that are together. And of course, it can go into microstructures, it can go into exciting research for our scientists, but I will just leave it for now and go directly to the processes. So advancing fabrication means cutting the cost, and cutting the cost can be achieved with a big step forward. So the first idea was like, when we look on the toys that are produced in China, those are injected in the molds. So high pressure injection of plastics allows you to very quickly fabricate huge amounts of the same components without any human interventions. And we said, like, if there is such a capacity in our institute, why don't injecting the ceramics? And we have introduced this process. We collaborated with Sumitomo Denmark, and then by fine-tuning the machinery, we were able to get to the cells which are produced in such a way that we are just injecting the supports, and by that we shortened the production time 10 times, and it takes 6 seconds for a single cell to be fabricated. But most importantly, we reduce the process waste by almost 25%, which means that the process is becoming very effective, and the technology is becoming cheaper because we are doing this in a shorter time and with less waste. Then we said that this should be scaled up, so we typically never produce less than 100 cells at once because it is just a sufficient number for our activities. Then we said, like, okay, this was a cell, but then we should go to the stack design. And if we think about the stack, it is a structure that has to be gas tight. it has to interact with hydrogen, it has to interact with oxygen, be exposed to temperature above 600 centigrades, and it should be robust, so we should be replicable. And making something replicable typically means to remove a human error. So we said that let's automate the production by introducing the 3D printing of seals, which actually accelerated the production time 5 times, and the waste of material was cut by 2/3, by 67% actually. And this is just related to the fact that we never cut a seal from a sheet, but we just produce it in situ whenever it's needed. And this is also another benefit in terms of the cost. And this is, of course, coupled with number of investigations and even 3D printers, 3D printer developers who are our contractors within that. And eventually, it is becoming a system. So I selected 3 systems that are, from my perspective, the most exciting. First of a kind, reversible unit. When we talk about the integration, I want to mention that a couple of years ago, when I was fully based in the US, I was looking on the system that Boeing and Sunfire developed for the US Navy. It was 120 kilowatt reversible system, and I was investigating the unit, and I said that there are a number of errors in the design and number in errors in terms of the functionality. It was a huge system, very obsolete, extremely big heat exchangers, and the performance was 34%. And I said, like, let's build something like that in Poland, but make it slightly smaller but more efficient. And actually, we have achieved the goal. And in December 2023, the system was on site. It was a 10 kilowatt unit, pretty small, but it was providing sufficiently high amount of representative data, and we achieve 43% electrical efficiency, round trip efficiency. Electrolysis, 89%, then the fuel cell mode, 47%. If you multiply 1 by 1, it gives you the number. And it started with the power unit. As we are Institute of Power Engineering, we seek for the power plants. We found the power plant. We said that there is a turbine, and the turbine is running on with a boiler. It's a biomass boiler, so it would be a zero emission electricity. So if this is a zero emission electricity and zero emission steam, why not converting this to a zero emission hydrogen? And the idea was to just take a part of the steam to feed the electrolyzer, and we did it. The turbine had a couple of sets removed. It was adopted to be able to draw the steam to the process, and eventually something like that happened. So we went to the existing system, the system that is a cogeneration site in the north of Poland with a couple of different units. The oldest are from the 50s. The newly built biomass boiler is to the right. And when I was flying the drone, I realized that the construction of the power plant was spanned across 50 years. And this is actually the dilemma in terms of hydrogen technologies, that quite often we need to get back to the old technologies to repurpose them and retrofit them to be part of the hydrogen economy. What you're going to see here would be the containerized electrolyzer, and then there would be steam line. There's a control booth and as well the compression house. So it would be just nicely to remember that the electrolyzer is the smallest unit. This is the control house, and this is the compression and hydrogen storage unit. But we wanted to demonstrate that there can be a power plant retrofitted to work as a system with hydrogen production capacity. And also the electrolyzer can be operated as a fuel cell mode, which will be our power booster. We have recorded the profiles in electrolysis mode, in the fuel cell mode, and then we started multiplying the numbers, and under different mission conditions, we were always above 42% electrical efficiency, round trip efficiency. What is worth mentioning here, and this would be very exciting for a power business. If you look on the bottom line, this is an explanation how a power plant works like. There is an operational window that is defined by the technical minima, so the power unit cannot operate below 40-45% of the nominal load, and there is a maximum capacity. And what we wanted to demonstrate with this system was to show that if you take a reversible system, on one end, it can take the steam from the boiler, and you don't have to shut down the boiler, because you're going to draw the steam and you're going to feed it to the electrolysis unit. So no stopping of the boiler, the combustion continues. The turbine can be not driven, but the electrolyzer can take all the steam. And on the other end, if you look on the right-hand side, if the power plant achieves its maximum capacity, maximum load, you can reverse the system into a fuel cell mode. You can use the hydrogen that you stored on site, and you can add to the power. So actually you are not just increasing the modulation of the system, but you are lowering the technical minima and you are increasing the power. So you can consider this as a peak power mover, which will be a power booster for the system. And then of course we investigated this in the heating mode as this is a CHP plant, and we said that there is a rule of thumb that if the system is 30 megawatt, we can integrate it with 8 megawatt electrolyzer, so 1/4. 25% can be sufficiently big. And how should we understand that? If you will imagine that the boiler that is using biomass to produce steam is not feeding the turbine with the steam, but is just driving the electrolyzer, it can be 8 megawatt against 30 megawatts. So this is a pretty nice reference. But of course you can have some extra degrees of freedom. For instance, you can decide, would you rather prefer to take more electricity or less steam, or you would like to maximize the uptake of steam, and there are several options. And in cogeneration, you get even more number of degrees of freedom. And then we decided to scale it up, and then we went to the refining plant after investigating the conventional power plant. We wanted to build a big system, but our customer on site, which was an Orlen company, said, but guys, we have just a couple of vehicles, personal vehicles, or maybe 2 buses. Don't build anything bigger than maybe 50 kilowatt PEM. And we said, like, no, but we're not going to go for PEM. We'll produce the same amount of hydrogen, but with solid oxides. So how big is going to be the system? And we said, like, if the PEM would be 50 kilowatt, we can achieve the same goal with 30 kilowatt solid oxide, because the performance is so excellent. And we got contracted for building this high purity hydrogen production 5.0, which means 99 and 999 in terms of the quality. And I think it was also a record-setting project that from signing the contract to completing the full operation, it was 28 months on site in the regime of a refining plant. And after this experience with the refining plant, we said, like, let's go big and jump at least 1 or 2 orders of magnitude larger. And we said, like, we have an option to enter the refining plant of Orlen company, who is our multi-energy complex. And we said there is a nice refining plant in Gdansk, and it can be our playground. And after strong negotiations, I was able to persuade the management of the company. At the same time, they sold it to Saudi Aramco, so then Saudi Aramco got involved in the process. But eventually what happened that we receive federal funding, a bit less than 26 million euros, and we are coordinating this activity, which has 3 phases. We completed the feasibility study and all the safety codes and permits. And now we are constructing the 0.5 megawatt prototype module, which is also reversible. And upon completion of this exercise by November this year, we're going to be multiplying this times 12 to have a 5 megawatt unit. And actually, you can see the rendering, how it's going to look like. But what is most exciting is that in all these processes, our team is involved along the entire value chain. We start from the labs when we are working on a single cell, and the same guys next day gonna turn into those uniforms. We're gonna turn into those uniforms working on site. You can say that I'm not in the picture, but there is always somebody who has to take the picture. That's the reason in principle. But those are the key engineers and people like that are responsible for the system. So you should expect some nice updates by the end of the year on this unit. But I just want to say one thing, that when we were establishing the team and the Center for Hydrogen Technologies, there were none of the systems with electrolyzers or reversible systems in Poland. Currently there are 4, and all of them are built on our patents, and 3 of them are built directly by us. So I can say that there is just one hub with the knowledge and the technology in Poland. And without further ado, I just want to say that we're just trying to make hydrogen available for everyone and make it simple. Thank you very much.
Thank you for this exciting speech. Happy to know that in the Central and Southeastern Europe, we start with innovations and we go forward. So please, I'm sure there will be questions.
Good morning. Thanks for the nice presentation. Hivir Guyen, Exion Hydrogen. 2 small questions. And the nice project you showed there, where is the steam coming from? And the second one is like, what is the pressure of your, because you mentioned 200 bar after compression, but what is the pressure coming out of the solid oxide electrolyzer?
So there were two options that I was presenting amongst other systems. One was the steam from the biomass boiler, and so it was a steam from the steam cycle in the power plant. The second was the steam from the refining plant, which is just available on site as they are running the steam reforming of methane. We draw part of the steam, but then of course we can use waste heat streams directly to heat up the stacks directly or indirectly. And currently we are working on the same system design for gas turbine. It was also our previous activity in the US we did, but generally it is open for options. I cannot show you the details, but we also partner with well, I can say GE Hitachi on integrating this with the reactor on an 8 megawatt scale. Yeah. And then the second question was pressure. So these designs are atmospheric. We have pressurized our stack. Currently we are able to run the stack at 12 bar, the 5 kilowatt module, because we built a pressure vessel last April in 2024, running a couple of experiments. And I think this is one of the 4 facilities in Europe that can pressurize stacks of solid oxide electrolyzers. Yeah.
Other questions? No. One question about the durability, and we know that in solid oxide mode, the degradation is lower than in electrolyzer mode. And when you work reverse, what do you notice? Is the degradation depending on the percentage of working in one direction, or do you have some data about the two modes and the combination between them?
I know where it gets to. A couple of years ago, Mogensen published a work that when you reverse, it will be a healing effect. But the problem is that the frequency of changing the mode would be so rapid that no business gonna need such a system. That's why we terminated working on that. We did not observe the healing effect as we were switching the mode maybe 60 times maximum in the same stack, and then we said, okay, if there is no visible change within the first 20, 50, 60 cycles, then we stopped. And of course it is mostly related to the system design, so we don't see that the degradation of the stack itself is a problem. The problem is if you have a fault of the components, and the BOP is responsible for 80% of the failures in the systems. But of course, electrolysis becomes tricky when you do co-electrolysis or carbon dioxide electrolysis, but the degradation is standard, and we benchmark ourselves against Elcogen, Sunfire, and Bloom, and those are the same numbers that we report.
I'm asking you because there is one innovation in solid era. They combined it with one the company, I forgot the name. However, they are using only in electrolysis mode, but they are using from time to time reverse. I know the effects of the reverse. The reverse is decreasing the degradation.
It does. Yeah. So it can help you
that's why I was curious to know if you have some observations in this.
It helps to rearrange the structure at the crystalline level, but at the system design we can handle degradation in so many other ways that basically adding this feature will not break even, because still you need to replace the stack every 5-7 years. So actually adding doubling the cost just to shortening a bit, it does not break even. So we basically don't consider the option of having this reversible for healing or limiting the degradation as a solution at this stage.
Yeah, on this stage. And the last question about the critical raw materials, which is a very critical topic. I saw you're decreasing the cobalt. What about the nickel? Because it also enters in the second list of critical raw materials. And
that's true, but my personal perspective is that if I go online today, I can buy within 15 minutes 20 tons of nickel, and it will arrive in 6 weeks to my facilities. If I'm considering cobalt, I will have to fill in a lot of forms and go through a number of procedures. Okay. So my engineering intuition says that I should not worry about nickel at these days. However, we are not investigating escape from nickel. Nickel makes 88, 89% of the cell. per mass. So it would be a disruptive change of the technology, and it will be a huge effort that we don't want to pursue at this stage.
Well, thank you. I like this answer.
Yeah.
Thank you very much once more. If there are no questions, the coffee is waiting for us. So break up to, let me see, 11, 10 past 11, please. Yeah. You may take your seats together with your coffee. Yeah. Yeah. Sorry to disturb you, but it's time to take your coffee with you. So it's time to continue with the second part of the morning session, and we're going to listen to a talk on leasing the hydrogen market in Greece. We are going to the southeast point of our region, and I would like to give the floor to Cleopatra Avram, Senior Director of Strategic Planning, DESFA. Please.
Hello from my side. Thank you for inviting DESFA in this event, and personally myself. I would start with a short description of who is DESFA. DESFA is the National Natural Gas Transmission System Operator in Greece. We own, operate, maintain, expand the natural gas transmission network, as well as the LNG terminal in Revithoussa. We have been established in 2007, and in 2018 there was a privatization process where DESFA was bought by a consortium, the Senfluga Consortium, which consists of 3 major European TSOs, Snam, Enagas and Flaxis, as well as a Greek energy company, Damco. They own the 66% of DESFA, and the remaining 34% is owned by the Greek state. Through these years, you have seen we have done a lot of milestones. Of course, the most significant one is the privatization, and in 2024, of course, and in 2020, we have been also involved in other projects. So what is our strategy? What is DESFA strategy? DESFA strategy focuses on 3 main pillars. First of all, we have the natural gas. It's obvious, it's transportation of gases is in our DNA. So natural gas is what we have been doing for so many years, focusing, of course, on the security of supply for our customers and for our users. But in the last 6 years, we have been working for 2 other gases, and these are the CCS and the hydrogen. CCS, we have been developing and maturing a project for the creation of a CCS hub in Greece, the first hub for transportation of CO2 liquefaction in the southeast region. Of course, I'm not here today to discuss about CCS, but about hydrogen, which is also incorporated, if I can say so, in our DNA. We have been working hard for the last years for the infrastructure part, of course. We are not producing hydrogen, and we are not involved in the production of hydrogen or in the consumptions, but our main aim is to develop all the relevant infrastructures so that green hydrogen can be transported from Greece to Central and Southeast Europe. How now we can achieve these 3 pillars that I have mentioned before? First of all, we are expanding our network. We are proceeding with a significant 10 years development plan with infrastructure of more than 1.4 billion. All of them, although they may transport in the beginning natural gas, there are 100% hydrogen-ready assets. And I mean pipelines for internal transportation, but also interconnections. We have developed also a path to a net zero operation strategy, so we're trying to minimize our emissions, focusing, of course, always on sustainability. And, of course, we are trying to become partners in a lot of other companies. But let me skip all these and proceed with hydrogen, deep dive on my presentation and my speech about unleashing the hydrogen in Greece. What we have seen from the studies that we have already conducted is that in Greece there is a huge potential, as you can all imagine, based on the location and the good weather that we have for production of hydrogen. We expect that by 2030 we will be able to export approximately 20 terawatt hours. You will ask me where is the end location of this and if this production will be consumed in Greece. Of course, this is not yet the case. As I mentioned before, natural gas is still transported in Greece, it's still used. But we see that there is a huge potential to transport this green hydrogen, European hydrogen production to Germany. What we have done, we have already assessed the market through a non-binding call of interest, apart, of course, for other studies that we have already executed. This call of interest, the non-binding one, was launched in September and was finalized in December. You can see here the results. 33 companies with their projects participated. Most of them, of course, were related to the energy sector. One chemical company and one pharmaceutical company also shared with us their data, mainly for consumption. For concerned consumption of all types of hydrogen, power production, and of course, pharmaceutical industry. And we had also received 4 replies for trading. The strange thing is that we have not received any reply for importing hydrogen as a trading aspect, while we see that, of course, in the next years, apart from the produced hydrogen in Greece, there will be evident also the need to import hydrogen and export it also as well. In aggregation, the numbers show that 40 gigawatt hours per day could be exported from Greece. You can see here we refer to a production of 72 gigawatt hours per day, while the consumption, the data that we received, refer to approximately 32 gigawatt hours per day. Where is now this production and consumption located? It's not in a specific region. Most of it, of course, as far as the production is concerned, is in the north. I don't know if you have heard about West Macedonia region. It's a region where already exists a hydrogen-ready pipeline, a pipeline that will transport blend at the beginning, and then it will be repurposed to 100% hydrogen, but it's already there. So there is also the production and the transportation method, and of course the consumption. It's the first valley in Greece. But this is not enough, let's say. What we have been all for this time developing, of course, is a hydrogen backbone, is the Greek hydrogen backbone. You can see it in the map. We refer to a hydrogen-ready pipeline, a PCI project that is interconnected with Bulgaria. It's the Hydria project. The Hydria project received also funding from Connecting Europe facility in the last CEF call for the studies, of course. And we're very proud for that because we can start maturing more this project. It's a pipeline of 570 kilometers long from north to south. The capex, the related capex is 1 billion. We have assessed that most probably two compressor stations will be needed with a capacity of 60 megawatt hours in total, and the interconnection capacity with Bulgaria currently is at 80 gigawatt hours per day. You will ask me, okay, this is a pipeline, but where does it go? As I mentioned before, this pipeline is interconnected to a twin project in Bulgaria, another 100% ready pipeline, and as you will see in my next slide, of course, it's interconnected with other pipelines that arrived in Germany. Now, what is the vision of DESFA and why we construct this big pipeline, which is, let's say, just a backbone? As I mentioned before, we are constructing and we're already building hydrogen-ready pipelines. You can see them in the map in red. We have a red pipeline, a hydrogen-ready pipeline in east, in the north. These are currently under construction, and of course, we envisage that these pipelines will be also interconnected to our hydrogen backbone, so we will create a complete network for hydrogen, for transportation, for every single point in Greece, also to export. So what is the correlation of this pipeline I mentioned before with Bulgaria? You can see we refer to a corridor, to the Southeast European Hydrogen Corridor. Is one of the 5 corridors also in the hydrogen backbone. We are collaborating closely with other 7 and lately will be 8 TSOs in Bulgar Transgas, FGSAID. You can see them there, Ustream, Net4Gas, OGE, and of course, Natran will be also included in this collaboration. We have already signed MOU and NDA. We refer to a corridor of 3,200 kilometers long. You can see that only 25% of this corridor will refer to repurposed assets. So most of it will refer to new pipelines, new hydrogen-ready pipelines that will need to be constructed and be there by 2029, with a total capex of 7 approximately billion. This hydrogen corridor, of course, and all these projects have been applied for PCI status. Some of them have already received, like the Greek and the Bulgarian one. Of course, in this PCI process, we expect that all projects will be included, so they will be also eligible for funds. Because as you can imagine, a very, very big challenge of all this corridor, apart from the collaboration of so many countries and so many TSOs, is the funding aspect. So just to finalize, why we see that this hydrogen backbone is very useful and will create new opportunities. You can see them here in the three stacks. Of course, it's very important for us to proceed with this corridor so that we can address the supply in Germany quickly, cost-effectively. We have done several studies showing that production of hydrogen in Greece can be very, very cost-efficient in comparison to many other corridors and to many other import points. Of course, we expect that through this hydrogen backbone, we will be able not only to connect to the Southeast Hydrogen Corridor, but maybe also try to assess other routings for the export of hydrogen, even through Italy. Already PCI projects have applied in this round for interconnection to Italy. And of course, we want to leverage on the extremely good renewable mix that Greece can have to proceed with a cost-efficient hydrogen production. So that's all from my side. I'm happy to receive any comments that you may have, questions. Thank you.
Very concrete information. Yeah.
Yes, problem is one. You show us 33 terminals, 33 installations you have. So how many works of them? And probably you can announce what the price is, average price for 1 kilogram of hydrogen.
You mean that we received 33 offers, 33, let's say, projects in our non-binding call of interest? The price is not included. There was just a non-binding call of interest refers to an expression of interest from the producers, consumer and traders to explain to us where their project is, what is their capacity of their project, so that we can afterwards proceed with a precise simulation of our network. This was the main point of our investigation and our non-binding call of interest. We have not yet assessed the price, but as I mentioned before, maybe you already know, the price of hydrogen is very competitive in Greece. Maybe in the last auction you have seen that the price that Greek producers of hydrogen gave was pretty much €5 per kilo. So you can see that we refer to a very, very low price.
Thank you.
Other questions for this corridor? Yeah, please.
Hello, Jure Petruš-Messer. Just a short question. I realized that you have some production also planned on Crete.
Yes.
How do you bring the hydrogen to the mainland?
It's a very good question. We have received from a producer in Crete that they would like, there is a huge potential also in Crete. You know, the island has a lot of sun, so there is, all the goods are there, all the benefits for production of hydrogen. It's an element how we will proceed from that way. We know that there may be a need to transport this with ships. So we will need also to proceed with infrastructure for a regasification terminal, not liquefaction terminal, for a regasification terminal. We have not yet assessed that. Just as I mentioned, the call of interest ended in December. We know that there is production there. We think that most probably a pipeline, an offshore pipeline, would be quite expensive. But as you can imagine, we need to proceed and assess both options. It's in our next, let's say, steps to see how this will proceed.
Other questions? If we go again to Crete, as far as I know, there is a hydrogen valley. I don't remember wasn't it a big one?
No, it's a small one, mainly production, consumption. There are, there are many small valleys for hydrogen in Greece, but mainly they are valleys in the perimeter of the industry. So they don't include transportation, networks, and all these things, which is, of course, our view and
so it's 500 tons per year, and that is for local industry. What is the perspective to have more capacity on this island, which is, in any case, with
in Crete?
Yes, with a territory which,
as I mentioned, there is
fixed.
You're right. There is huge potential in Crete, but there is no network. So I don't know. In Crete there is no industry, so they cannot. They're not power plants, so they cannot consume this hydrogen. It will be just produced for export. We need to assess if the infrastructure is feasible first, if it's economically viable, so that this hydrogen can be transported to the mainland and then either used or exported. But this will take time. You understand the point. Our corridor aims to be ready by 2030, the latest. Parts of it by 2030, based on the cooperation that we have with the other TSOs. I'm pretty sure that a network from Crete will not be ready by 2030.
And when we talk for Greece, everybody connects Greece with the sun.
The sun, yes.
And beaches, of course.
And islands.
And that means solar energy. However, Greece is, well, a sea territory. Yes. What about wind?
Yes, indeed. Most of the projects that we have received in the non-binding call of interest were from solar. So photovoltaics that will be used to produce electricity and then with electrolysis hydrogen. There are projects for wind, even offshore plants, but they are not so mature currently. I know that our ministry supports offshore wind electricity production, but there are not yet so concrete plans, let's say. But of course, we see also that there is a potential. In Greece, based, as you mentioned, on the sun, there have been given many licenses for production of electricity through photovoltaics. The case is that this electricity cannot be secured if it is injected in the electricity network. So somehow, if these projects need to go on and their promoters proceed with this project, they need somehow to use this electricity, this production of electricity. So the only way to do that is through hydrogen.
Yeah. And it will be good to combine solar and wind, because in this way, of course, the working hours for renewables are increased.
As I mentioned, we have the assessment is based on the best renewable mix. That is why, based on this best renewable mix in Greece, we have a very low price of hydrogen.
Well, once more, thank you very much.
Thank you. Thank you.
So we rely on the southern parts of Europe. Now we are going online. We are going to have our Ukrainian colleagues. The next presentation is development of hydrogen projects in Ukraine, projects in Odessa and Zakarpattia. Yesterday we learned a lot for the connection with Slovakia, and we're going to listen to Yaroslav Kryl, who is CEO of Hydrogen Ukraine. Please.
Hi everyone. My name is Yaroslav Kryl, and thank you for having me online. I hope that in nearest time situation will change and Ukrainian men can travel abroad. But nevertheless, today I am glad to introduce our Ukrainian projects, which we develop even during war time. So in our company have two projects in our portfolio. Our headquarters based in Kyiv, but projects locates in western part of Ukraine in Zakarpattia, close to Slovakia border, and in Odessa region, close to Moldova and Romania border. I'll start from Zakarpattia's project because yesterday our colleagues from Slovakia presented their projects, and as we created with them a consortium which is currently under grant agreement preparation, we expect to start this spring feasibility study for hydrogen production plant. But in previous years, we made a lot of preliminary studies, like a pre-feasibility study for hydrogen production. Also, we evaluated water supply and water resources for sustainable water supply for electrolysis. We evaluated regional power network, how to connect not only renewables to energy system of Ukraine, but also how to make some mix of renewables and connect them to electrolysis plant. So our project was certified by Mission Innovation and Clean Hydrogen Partnership as a Global Hydrogen Valley project. We expect to transport hydrogen through future Central European Hydrogen Corridor, which obtained PCI status at the end of 2023. Our company was indicated as a project supporter in the official website of Central European Hydrogen Corridor. And for us, it's very important because the cheapest way of hydrogen transportation, it's around 10 to 50 euro cent per 1 kilogram of hydrogen through 1,000 kilometers. Last year in December, after a Ukrainian Recovery Conference, we signed an MOU between main stakeholders of future hydrogen road from Ukraine to Austria and Germany. And we expect to make a very deep collaboration on this purpose. And we are ready to share with all stakeholders all our insights and all our studies, which we already developed in frame of our, I'd say, a flagman project, which locates in Odessa region. This project was first Ukrainian project which obtained certification from Mission Innovation and Clean Hydrogen Partnership. Previous speaker told about important of Greece connection with European off-takers of hydrogen through gas and future hydrogen transmission system network. And I tell you that project in Odessa region could be connected to this south and east hydrogen corridor through Trans-Balkan corridor. And in the initial stage of our project, we expect to build 100 megawatt of electrolysis plant with 200 megawatt of renewables. But yeah, you see this slide start of construction 2026-7, but all will depend of current situation in Ukraine. For our project, we made in 2021, we finalized preliminary feasibility study. We analyzed renewable energy sources in Odessa region. We calculated the best option for and best combination of renewables to achieve the highest number of operating hours of electrolysis with the lowest cost price of hydrogen. It means that for 100 megawatt of electrolysis, we have to build 200 megawatt of renewables, which consist of 60% of PV and 40% of wind generation. Also, we evaluated water resources with Institute of Geological Science, National Academy of Science of Ukraine, and we taking into account the possibility of scaling Hydrogen Valley in Odessa region up to 3 gigawatt of installed electrolysis capacity, we can tell you that water consumption and water intake from the Danube River for such amount of electrolysis production will be only 0.0036% of average annual water flow of River Danube. As our project, as the main option for transportation for our project, it's hydrogen transportation through the pipeline because it's the cheapest way. We also made several additional calculation how to transport hydrogen to the Central European countries using ISO containers by the Danube River. This approach shows the highest prices with comparison of transportation hydrogen using pipeline. In 2023, we created a consortium with British lead company EBFI Consulting and participated in British funding program. Our applications has been successful and we received a grant offer letter, and since April 2024 we start implement and start doing comprehensive feasibility study for our project. So we expect to finalize our comprehensive feasibility study by the March of 2026. Our comprehensive feasibility study consists of 4 key elements. First one is feasibility for hydrogen production. Second one is feasibility for wind power plants and solar power plants, their integration with electrolysis plant and the energy system of Ukraine. Third, it's a study regarding hydrogen pipeline construction. And fourth one, very interesting study regarding geological substantiation of sites and possibility of construction underground hydrogen storages in saline formation of southern part of Odessa region. This slide you see a helicopter view of our project. We expect to scale up we expect to build 2 phases of project. At the first stage, 100 megawatt of electrolysis with possible scale up to 200 megawatt, and the same with renewables from 200 to 400. On this slide, you see helicopter view for the initial stage. Currently, we have already finalized technical part of feasibility study of electrolysis plant, but I have to tell you that our project is unique because we don't concentrate on one option. We have already calculated 3 options of hydrogen utilizations for Ukraine's reality. First is definitely pure hydrogen production. Second one, it's green ammonia production, which could be used as a raw material for future fertilizers. By the way, before full-scale invasion, Ukraine took around 7% of European ammonia market. And third element, it's very important for Ukrainian economy, it's methanol production. In our case, it's green methanol. It's very important to note that currently in Ukraine there is no any methanol production because Russian forces destroyed all our facilities, and we have only one plant which located in Lugansk region in the city of Severodonetsk. And in our case, on a hydrogen megawatt electrolysis plant with the option of methanol production, we could produce more than 83,000 tons of green methanol. This amount could cover all Ukrainian needs of methanol. currently, as I mentioned, we have already finalized technical part of our project, and we are under financial part. We are under finalizing our financial part, and I will be able to tell about cost prices, not only for hydrogen, but also about green ammonia and green methanol by the end of March this year, because in March we expect to finalize all this calculation. Very important for electrolysis production to secure own renewables, because only own renewables allowed to reach the lowest, allowed to obtain the lowest price of electricity, and the lowest price of electricity is the key for achieving the lowest LCOH. Currently, we are under calculation and are under a modeling of energy system of Ukraine, especially in Odessa region, and we approaching for the obtaining technical requirements for a grid connection. I believe that in nearest months we will got all this. We will achieve this very important target. But I'd like to highlight that in frame of our feasibility of renewables construction and their integration into Ukraine's energy system, we try to calculate how to connect to Moldovan's and Romanian energy system, because through Reni local community, where we expect to build our hydrogen project, is built only one high voltage line which connect Moldova and Romania, and we try to make some calculation how improve this connection, which allowed not only to our project, but it will mitigate all risk regarding connection between NSOE and energy block Ukraine-Moldova. In frame of our feasibility regarding hydrogen pipeline, you see on this slide three options of construction of hydrogen pipeline from our side in Ukraine to possible off-taker of hydrogen in Romanian city Galati. It's a steel factory which announced their green reconstruction, and we already performed three possible routes of future hydrogen pipeline construction. Blue line, it's a hydrogen road through Republic of Moldova. Purple line, it's through the Danube River. And for us, the main option, it's red line, because it explores the possibility of development, individual technical norm of connection hydrogen production to existing gas transmission system network for future hydrogen supply. Because I see a lot of projects which provide some opportunities for transportation of hydrogen, but less of project tell about technical possibility. And in our project, we are working of readiness of future hydrogen supply. We try to invent unified technical requirements for such connection, and provide it to interesting projects, interesting countries who are interested in similar connection. And also, it's very important to note that existing gas transmission system network should be testing for readiness for hydrogen transport, and we closely collaborate with Ukraine's TSO operator in this purpose. And last but not least, in the southern part of Odessa region, between cities as Kilia and Ismail, we have a huge salt deposit, which could be with a deep of 400 meters, which could be used for future hydrogen, underground hydrogen storage construction. In frame of our study, we collaborate with the Institute of Geological Science, National Academy of Science, and we have already done field studies for interesting area. We have already made more than 200 observation points where we collected samples for analyzing geochemical and structure properties. In our analysis, we are focusing on hydrogen, underground hydrogen, helium, radon, and hydrocarbons to analyze in lab geodynamic stability and low permeability for future possibility of underground hydrogen construction in solid formation. We expect to finalize this study by the end of July 2025, and we'll be ready to share information regarding possible amount of hydrogen which could be stored in the future underground hydrogen storages in the southern part of Odessa region, close to Romania border. So we always say about future. So our slogan in our company, join the future. So thank you for your attention and join the future. If you have any question, I will be glad to answer for it.
Thank you so much for this presentation and for those very ambitious plans. Congratulations for this. Please, yes.
Well, Alexander, thank you very much for your presentation. If in such circumstances what there are now, Ukraine has such big plans, it means that Ukraine will have a very bright future. But my question is regarding hydrogen. Now I understand that everything is in a state, in a governmental level, and only few companies, they are attracted to make feasibility studies and other things. But when you're gonna install such capacities, what the plan is, how to attract funding? Or it be Ukraine government money, or you are gonna to attract private developers, how it is?
Thank you very much. It's very important questions for such initiative as our company. And for us, the main target is participation in European Hydrogen Bank auctions. But to participate in it, we have to finalize our feasibility study and reach FID stage. So we have a consortium for each project, and I guess and I believe that after finalization our feasibilities, the next step will be participation in such initiatives like EU Hydrogen Bank.
Other questions? Well, your company is part of the Hydrogen Association, or the Hydrogen Association is something like company. What is the connection between the association and the company? I think that the company is doing well, not alone, but is the coordinator of the feasibility studies.
As we are a private company, yeah, definitely we are a member of Ukrainian Energy Association, Ukrainian Hydrogen Council. Association provide us full support in our activities, and we collaborate with them very deep.
Yeah, that's nice to hear this. Now, the plans are ambitious. Finances are an issue. However, even if you have finances, you need human potential and capacity. And that is something very rare to find it all over Europe, not only in Ukraine. What are you thinking about people, educated, skilled, that have to build all this about which you are talking?
Yeah, you know, I'd start maybe firstly from this question because people's potential is the main issues for each hydrogen project. In our case, we collaborate with Ukrainian university. We have collaboration with Zhytomyr Polytechnic Institute and with Kyiv Polytechnic Institute. By the way, with collaboration of Kyiv Polytechnic Institute, we developed educational programs for master's degree. Maybe several in January it was presented and public hearings took place. I expect that this educational program will start next year, and our unique Ukrainian university will start educational program for future specialists in hydrogen economy and for hydrogen sector.
Thank you for this answer. I want to give you some information. In practice in Europe, there are only 3 real programs for master's degree, which really cover the entire value chain. And it's difficult to create alone a master's program for good education in hydrogen technologies. However, there is one European project, European Hydrogen Academy. In my presentation, which will be today, I have put a link. You may see it, but I'm in contact directly with you. We are making universities and schools network online, and we are preparing teaching materials, 10 university books and some school teaching materials. So I would invite the universities to join this network. We work with Ukrainian colleagues, and I'm excited from their enthusiasm and capacity. And I think that may be beneficial for you. Thank you.
Oh, so, it's amazing, and I will be very happy if we will make this connection with our Ukrainian university with your projects, and yeah, I am excited to listen to your presentation today.
Okay, thank you. Some other questions? Well, once more, thank you, good luck, be ambitious, and realize your ambitions. We are waiting for you to join.
Thank you very much. Yeah.
Bye.
Bye.
So now we are running to the next presentation, which is First Transnational Hydrogen Valley. It is given by Yuri Giacomelli, NAHV, whatever it means, Communication and Dissemination Manager, the Adriatic Hydrogen Valley. I suppose that is a part of the big hydrogen park about which today we have heard.
So
please,
if
it is also online. So
Daria, they have Daria.
Yeah,
they have a bit problems with connection. So if we can jump into your presentation, if it's okay with you.
Okay, so the floor is mine. I don't see the pointer here. Oh, okay. Thank you so much. Well, I do not need this. Good morning to everybody once more. My name is Daria Vodikova. I'm a scientist, but in Bulgaria, science is a driving force for deployment of hydrogen. So I'm a founder of the Bulgarian Hydrogen Association, and the aim of this association is to combine efforts of science, industry, and policymakers so that we should accelerate the deployment of hydrogen. That is the outlines. In practice, I shall touch every point, but not in this order. The kernel of my talk will be the national roadmap, which is which is called National Strategy, which was officially accepted in 2023. To be honest, we started to work on the national roadmap or strategy as association from 2019, following several aspects: analysis of current hydrogen consumption and assessment of hydrogen demand, potential areas for hydrogen integration, standard sectors and new sectors. And the final goal is to evaluate the needs and to see what is the capacity. We also continued further and to start with the analysis of the demands. Unfortunately, I have to say that we started with the dangers. Dangers can be also a driving force. So one of the most carbon-intensive sectors in Europe, that is the Bulgarian, unfortunately. We have the biggest refinery in southeastern Europe, unfortunately Lukoil, but in the moment Lukoil is selling the refinery, 80,000 tons per year. We have a good ammonia production, but the worst is the thermal power plant, which is on coal, low quality, and it is 3.6 gigawatt. You know, Polish colleagues know how difficult it is to persuade miners that they have to change to renewables. However, we have positives, and they are oriented toward the future. The positives are the sun, similar to the Greek one, 1,600 hours per year photovoltaics. We have already 4.5 gigawatt installed capacity. We have potential for more than 40 gigawatts. In respect to wind, we have less than 1 gigawatt, but combined offshore and onshore, we are going to have capacity for more than 80 gigawatt. We have hydropower from 2.4 gigawatts. I don't think that we should increase it, but in any case, our nuclear 2 gigawatts is going to be increased. So to be realistic, of course, if things go well, after 10 years, we suppose that we shall have about 20-25 gigawatts renewables, which means that we shall need storage, and that means that we shall need hydrogen. Now to go back to the high level of CO2 emissions, ammonia and refinery connected with industry need hydrogen, and Bulgaria produces about 5% of the hydrogen, gray hydrogen in Europe. So it is worth to decarbonize this industry. But of course, the problem is with the coal and with the thermal power plant. And that's why when making planning, like our Ukrainian colleagues in 2019-20, we wanted to concentrate on the coal mining region In addition, the ammonia plant is only 30 kilometers from this region, and the refinery on about 180 kilometers, which means that it is worth to think for production in a big hub and for transportation through pipelines. In addition, the coal mining region has 250 square kilometers good land, which in practice can ensure 30 gigawatts photovoltaics. But we didn't want to use everything, so 10 gigawatts power from photovoltaics would be a reasonable number. And that's why we developed our Bilion concept, that is one of the 5 European lighthouse projects, big hubs. We developed it with the help of Hydrogen Europe for 8 gigawatt electrolysis. Of course, it's difficult to start from the very beginning, and we understood that we have to start from something smaller. That's why in 2022 we applied for a small hydrogen valley, and we succeeded to be granted. So now we have the CEE Hydrogen Valley for 500 tons per year clean hydrogen, and here the first unpleasant surprise came. The companies that wanted to work in this hydrogen valley went out of the consortium. In the moment we are looking for new companies. I hope that in the next months we shall solve the problem. But our analysis shows that the big gap is the lack of knowledge, of expertise, of hydrogen culture that covers the companies, the policymakers, the administration. And our mitigation strategies is teaching, skilling, and reskilling. We entered in 3 big European projects connected with skilling and reskilling. I already said enough about the Hydrogen Academy. Please, your universities and schools are welcome to join this network. About green skills for hydrogen, that is one big Erasmus project, a new concept for skilling and reskilling. Bulgaria, and being partner from this in this project, we are obliged to start courses, pilot training courses. Very successful. In November we had one. Now in March we are going to have another, and in April and May we shall have 2 more courses in different towns. Very high interest. We have to repeat them because we can't accept everybody. We have also training, so the number of people is limited. In any case, the next course will be also online. We can give it in English, and if somebody is interested, maybe we could organize online one European course. In respect to education and training, Bulgaria concentrated efforts in transport, in mobility, because that is really a business case. We want to develop expertise in mobility, and we started with one demonstration project, the first demonstration project in Bulgaria, financed by the Bulgarian Ministry of Education and Science, for retrofit of trolleybus with 100 kilometers range extender on fuel cell battery, so that we could accumulate experience and we can use this trolley after that for teaching and training. We are in the final stage in integration. I want to thank the Latvian Hydrogen Association, Ivars Sarikos, who helped us very much in the first steps towards this idea for increasing our capacity. At the moment, we are in a feasibility study for retrofit of locomotive in one unique and high mountain railway at this narrow gauge. And the last direction is to increase the capacity in research and innovation, because there we are lagging in the rear. We are happy to have the so-called teaming project for establishment of Center of Excellence in Hydrogen, again in the coal mining region, with new manner of research and innovation management and administration, because that is a big hurdle in Bulgaria. We are going to make model laboratories with the help of Italian partners, quite advanced, which are oriented towards business. We are going, for instance, to build test center for testing of 150 kilowatt fuel cells for transport applications. We have to attract young people, and this model should serve as a lighthouse for the changes of the Bulgarian research and innovation ecosystem. All this is included in our hydrogen roadmap, but we worked in some directions which in the moment are not included in the roadmap, but already our ministries use those directions. For instance, our analysis about the mobility in Bulgaria, and last month the data I'm showing here were adopted in the document which the Ministry of Transport should give for updating the requirements for implementation of the national policy in alternative fuels. Every country has to give such a report. So we have about 1,500 different kind of vehicles and 40 refueling stations, and we need for this about €1 billion. Stopped working. Oh, sorry. Another analysis connected with hydrogen in the Bulgarian economy. We are combining industry, transport, energetics, heating, cooling, and export. Rough estimations, 2.4 gigawatts electrolysis, and capex about 3.4 billion euro. And that is the distribution. You see, with these quantities, we can cover the decarbonization of our ammonia and refinery. We shall have balance of grid and injection in gas turbines. The transport is covering the requirements of a FIR, a little bit combined heat and power, and we are thinking for 83,000 tons per year export of hydrogen through the European backbone. And the most important is where the money has to come. That is our analysis. European funding, but funding which is shared management. That means funding from cohesion funds. It comes from Europe, but it is governed from the Bulgarian government. The National Recovery and Resilience Plan, Just Transition, Modernization, very important are the programs. We have 6 programs from the Cohesion Fund, from Regional Development, and here you can see the money that are entering in Bulgaria. And if we use only 5% from those money, but dedicated, well used, then we shall have 2 billion euro for hydrogen. In addition, we shall have some direct funding with projects. In the moment, with our Hydrogen Valley and teaming project, we have already 45 million. Then national funding, which is not too big for 6-7 years. Then private funding. Companies are ready to invest if they feel that the government, the state, is staying behind that. And I hope that soon that will become reality, because in the last 3 years we have elections in every 6 months. In the moment we have from 1 month government, which we hope that will be more stable. So total, we think that we can collect 4 billion euro. And now I want to say a few words for one action, and if you are interested in it, you can join it. Recently, we have a Bulgarian startup company, which is with ambitious plans to develop a complete ecosystem for hydrogen road transport through the TEN-T corridors in Central and Eastern Europe, and they should be connected with Turkey and with Asia. So the idea started in 2022, then we had feasibility study, not we, they, because I do not participate here. And now the company is established, and they are in the stage of building a pilot which should show if that is really a sustainable idea. That is the map of Europe. You know very well that our region is quite bare from refueling stations. There are big efforts in the cities for buses, but not efforts for trucks. And the big connection between Europe and Asia is passing through those corridors. So the idea of this company, CEE Hydrogen, is to develop 16 models of which will form one common ecosystem. Every module is a sustainable ecosystem. One module is marked with the circles with the same color. And in every module there are definite number of refueling stations. Some modules are in one country, other modules are in different countries, cross-border. Sustainability, according to the calculations, means about 200 trucks of a module. Of course, they may be reinforced with some buses, local buses. Though that is the planning of the refueling stations, a big part for the trucks and a smaller part from wide-duty vehicles. As I said, now there is a building of one pilot, which consists of refueling station, of one module which is for maintenance of the trucks, and a third module for training of the staff, skilling and reskilling. The idea is that this company, with one consortium, will be responsible from trucks, maintenance, refueling stations, production of hydrogen. Very ambitious, but very well calculated. So those are the coordinates of the co-founder and CEO, Bogoj Burdin. I'm his tutor, and I'm very proud with this, which he has done. The project is open for joining companies or organizations. Here is a representative of Resato, Roy Vincent, who is joining this initiative, and during the lunch maybe you could talk with him for more details. Thank you. Thank you, Roy. And the last thing which I want to touch, that is the European hydrogen backbone and the participation in Bulgaria. As already Cleopatra said, yes, we have one interconnection project, part of the projects of common interest. We are in the southeastern backbone. And the first stage is in feasibility study, 250 kilometers from Greece to Sofia. Now there is application for the second stage from Bulgar Transgas in cooperation with DESFA. And the second stage is from Sofia to the Romanian border, 330 kilometers. However, I would like to put the question and the discussion which we started with DESFA. Who will produce, where, and how? Only for the first stage, we need 1,500 tons per day hydrogen to use this pipeline, which is 3.3 gigawatts electrolyzers. There was one survey made by DESFA and Bulgar Transgas to ask who will use the hydrogen, but the question should be who will produce the hydrogen, and that is an open topic. In our opinion, we have to join efforts, all the countries that are through this southeastern corridor, which means Greece, Bulgaria, Romania, Hungary, Slovakia, Czechia, Germany, and Ukraine. And we have together to decide, to find building, who will produce the hydrogen, legislation, how this will pass through different countries, how different countries will take part of this hydrogen, maintenance, end users. I see that the Northern Corridor is already collaborating. We have to start this with the Southeastern Corridor. And one idea for joining efforts under the umbrella of the European Strategic Energy Technologies Plan. That is the umbrella of all clean technologies connected with energy. It is working with 13 implementation working groups. Hydrogen is existing but hidden, and in the moment we are working on a new hydrogen implementation working group. On the one side, developing hydrogen and hydrogen economy. On the other side, connecting the activities with the other implementation groups, which are all kinds of renewables, carbon capture and utilization, and so on. We are organizing the work in different so-called activity fishes, and our association is, let me say, responsible for hydrogen infrastructure in the Central and East European corridor, from feasibility studies to market deployment. So if you are interested, join us. That will be a good platform for starting discussions and for making connections between the associations with the companies, so that we shall make really one network connected with the utilization of this corridor. So thank you very much. Now we come to some questions. It's difficult for me to give myself a question as a chair. So yes,
somebody have to ask you as well. You ask so many questions you gave before, but as we see, every country, Bulgaria, Romania, Slovakia, Poland, everybody is going to produce hydrogen, and in quite big amounts. And what I see in every slide, all pipelines, they goes to Germany. Do you think that this one country will consume so much? And it be enough place in pipelines?
Yes, Germany can. I'm sorry that I'm talking on behalf of Germany, but the analysis shows that Germany can produce 15% from the hydrogen which Germany needs. And we talk today for resilience. We have to have several sources. That's the first thing. The second thing is that Bulgaria, Romania, and Greece are going to produce hydrogen. Potentially, we have potential, technology zero. You see, we can't start with 5 megawatt, but that can be overcome. We should do it. More than 50% will stay in the country because we do not want to export. We want first to decarbonize our industry and then to export and to help countries that can't produce clean hydrogen to decarbonize. So when we go to Slovakia, when we go to the Czechia, they are going to consume Austria. We made one survey connected with the implementation working group. We asked countries, are you going to import or to export? So we know that the countries in the western part of Europe are going to import. That is Austria, Netherlands, Germany, while UK can export, Spain and Portugal can export. Our corridor in the beginning will export and produce, and the other countries will import this hydrogen. So the final point is Germany, but all the hydrogen is not for Germany. And here comes the problem. For instance, Hungary wants to take some hydrogen. What will happen with the pipeline after that? Concentration, what will be the legislation, who is paying, who is responsible? Many, many questions. They are not only technological, which need thinking, legislation, but together.
Thank you so much, Daria, for this great presentation. I feel proud that I'm part of this region, which shall be so intensively decarbonized. Actually, I'm coming from the biggest region in transition on Balkans, Stara Zagora, which Daria presented on the slides. What I'd like to add and to ask is that in this just transition plan for the region, we'll have an open procedure focused on H2 value chain in order to attract companies, investors into the region, which to develop this industry also. So do you think that it could be a kind of, how to say, incentive for other foreign companies to come to establish their facilities in the region and to support creation of H2 value chain in Bulgaria and in this southeastern corridor also?
If my answer was no, I would not be here. So, you know, hope doesn't die. Hope never dies. That's why we are trying to educate people, especially that's very difficult region because miners won't go. We have just to change the manner of thinking. That's why we invest so much in education. I'm working in this region. I'm not living there, but I'm working there because it's difficult. And I'm working there from 4 years. And I'm not still disappointed. Only partially from time to time. Yes, there is future. Yes, some companies become more and more interested. We are going now to apply for a new hydrogen valley. And the people, I see that they are ready with calculations, with feasibility studies, with permissions for building electrolyzers and photovoltaics, something which we couldn't have 3 years ago when we applied for the first hydrogen valley. All the countries from our region are going forward. At the beginning slowly because the first steps are difficult, but I see acceleration. I saw wonderful examples with 10 megawatts. So yes, my answer is yes, yes, that will happen, but we need more time. If there are no more questions, it's time for lunch. Please, we have to be back here.
Daria, sorry, we have the online one.
We have already a line? Great.
Yeah, we just switched.
Okay, so we are going to the topic about the valley. We are going to first transnational hydrogen valley. Yuri Giacomelli, again NAHV, Communication and Dissemination Manager of the Adriatic Hydrogen Valley. Please.
everybody, and my sincere apologies for the confusion. I mean, it's really very unpleasant, position to be in. In between lunch and I mean this last presentation. My name is Yuri Giacomelli. I represent the North Adriatic Hydrogen Valley. And I'm the communication dissemination manager of our initiative. It's really a pleasure to be with you, and I really appreciated the speeches that preceded me. In this address, I'm going to acquaint you with our initiative, which is, of course, one of the several ones, and there are many more to come across Europe. The peculiarity is that the North Adriatic Hydrogen Valley is definitely the first transnational hydrogen valley in the EU, and to our knowledge, one of the earliest ones in the whole world of this kind. And definitely it has some added value that derives from that. It is an initiative that comprises the Italian easternmost region, Friuli Venezia Giulia, Croatia, and Slovenia. It definitely is open to Central and Eastern Europe, and has the ambition, of course, to actively transfer knowledge and competences and results earned in both directions in the Central and Eastern Europe. One important peculiarity is that this is an industry-driven initiative. So it developed bottom up. Another important point is that we really follow the so-called quadruple helix innovation model. So we unify partners from different types of partners, including industries, academia, policy decision makers, and we are working on engaging general public and business decision makers as well. It all started with a series of conferences and consultations that resulted in the political support that the industry players received in order to establish this valley. And the overall support of all four components of the quadruple helix model was decisive, and the quality of our proposal was awarded by the Seal of Excellence. So we understand that we have quite a responsibility in all that. The initiative started in 2023, so it's active now for about a year and a half. It received a grant of 25 million euro. It's a 6-year initiative with, of course, with the aim to assure the continuity of actions later on, and I will get back to that in a few minutes. It comprises 3 countries. When it comes to Italy, it's at the level of governance. The involvement is put at the level of the autonomous region Friuli Venezia Giulia, and of course the main goal is to create a market for renewable hydrogen, both on the demand and the supply side. So, listening to the previous debate here, of course, we foresee the uptake of hydrogen just as much as the production of hydrogen, and we are basically testing several technologies that could contribute to that. It's quite clear that the position of this hydrogen valley is posted aside the southern hydrogen corridor coming from across the central Mediterranean through Italy and going once more going north through Austria and to Germany and so forth. But still, some 20% of the target expected production of the renewable hydrogen is supposed to be exchanged between the partners of this initiative at the year 6. The final goal is to produce 5,000 tons of renewable hydrogen a year in the final year. There's a short overview of partners here. Aligned, on the from, according to their origin, coming from three different partners. It is so far it is quite foreseeable that there will be some more hydrogen produced in Slovenia and some more hydrogen used in Friuli, Venezia Giulia. However, there is no significant bias to that, and there's quite a clear plan how, of course, this exchange of hydrogen will be allocated among specific partners, as you could see, as you could imagine from this sketch. The focus of the industrial aspect of the project is on three main value chains or three main pillars: the hard-to-abate sector, energy sector, and the transport sector. The transport sector covers solutions both for the terrestrial transport and the maritime transport. This is a map of the so-called testbed projects where novel technologies are being applied and installed, and they start at TRL 6, and we expect to finish at least at TRL 8. For fuel cells applications are being demonstrated in selected test beds. In these following slides, I'm going to provide some more details on some specific test beds that have already started and achieved some initial progress. Not all of them have been that far. As you can see, when it comes to hard to abate, we've got cement industry well represented. There's roof tile producer in eastern Slavonia called Deal. There's with Italy's national the energy distributor Snam and its a regional branch Acegas involved that aims to produce 370 tons of hydrogen a year in a plant that will regenerate an industrial complex that has been abandoned, and it's now being in process of finalization and so forth. So I'm not going to go in all details in order not to take too much time. However, you will be able to see this in more details on your own. I mentioned that the overall financing of this project through the public grant was 25 million. At the beginning of the project, the estimate was that this project would move around 300 million euro of additional investments into the hydrogen-related technologies and solutions, and of course this was expected to grow. And on the right-hand side, there are just two articles published respectively in autumn 2023 and in autumn 2024, or towards the end of each year. So you can recognize, the figure of 700 million, which was the estimate of the cumulative investment to follow the initiative. And actually, towards the last year, we still accept this estimation as a valid one. The total estimate of the total cumulative investment expected to follow and already being in the implementation phase in all the projects is 1.4 billion euro. And this means that this mostly accounts for additional private money, but there are still more investments to come into the region through follow-up initiatives that are being piled up. We have launched a follow-up initiative called NACIP, North Adriatic Clean Hydrogen Investment Platform, where we have started to pilot additional 5 pilot projects. And there are 2 more projects in preparation, one more I3 initiative called NASCA, and one Interreg Alpine Space, Interreg Italy-Slovenia project, which is called H2 Ready, which targets local municipalities and supports local municipalities in the preparation of hydrogen storage capacities and the local hydrogen action plans. When it comes to skills and people, 3 universities are intensively involved in this process, respectively from Ljubljana, Rijeka, and Trieste. And they are working on several vocational training and academic courses, graduate and postgraduate courses. The first vocational training is about to start in the spring semester in Rijeka, and the 3 universities are preparing a combined set of courses which will be shared among the universities and will allow students to collect credit points from following several subjects in more than one institute of the 3. The characteristic of the cross-border or the transnational valley gives another important aspect of this valley, and that is the challenge of the regulatory framework. We understand, of course, that there's a fragmented situation right now, and that the EU currently still lacks a unified hydrogen regulatory framework. What is, of course, a major deficiency for the creation of a stable hydrogen market, and the certifications are missing. So this is clearly something that we need to address in our valley, because it's important to know how we will be able to regulate the trade, the cross-border trade of hydrogen. So to start rolling this out, we have, first of all, we have established that there are different starting points. Croatia has got its own national hydrogen strategy. Italy is about to complete one by the end of this year. Slovenia has got one specific national hydrogen strategy. There is an industry paper that was used as an input. I mean, industry-produced paper that was used as an input for the national energy and climate plan, where hydrogen is treated as one important aspect of this strategic document. So there are different approaches, and this is already something to take care of. And the NAV right now has been exploring innovative solutions to different techniques where the policymakers of all three countries are actively represented. It's worthwhile saying that the autonomous region Friuli Venezia Giulia is a member. As a partner, is a partner of the NAV, and four let's call them regional ministries are involved actively in the activities of this and other work packages. There is the Slovenian Ministry of Environment and the Croatian Ministry of Economy and Environment involved in this very work package dealing with the regulatory framework. So the regulation has got a high level of attention in our project. So the next steps include the benchmarking exercise between the three territories and the gaps identification, the preparation of policy guidelines and incentives, the roadmaps for Slovenia and Croatia, and the incentive scheme. And then, of course, the sandbox exercise means that Slovenia and Croatia will address the gaps by providing pilot solutions at the legislative level, or temporary solutions which will be tested through the implementation of the test beds. And so certainly there are some areas like the water transport that are of interest of all three countries, and will be also treated in this way. And there will be additional, when it comes to financing and so financial and other logistic support, the low TRL pilots will benefit from regional or national support. So this is also one aspect of direct involvement of the policy making. The next important element of the North Adriatic Hydrogen Valley is how to ensure replicability and inclusiveness. We are planning to establish a non-profit association under the Belgian law, so it is going to have a seat in Belgium. This association, or the so-called AISBL, what means the International Association with an international non-profit association, let's say, it comes from French, this governance body is going to assure the continuity of actions and also further inclusiveness. So all initiatives that I've mentioned before, and the NACHIP initiative is already up and running, also refer to this same governance body, which will assure the continuity and also the coordination between several initiatives in the future. So we understand that this is not just a one project operation, but it is the main pillar of a shared ecosystem between the three countries. So that's actually our message. And Najib, as I said, as the first follow-up project that is already active, that received about 8 million grant, and the initial value of 5 pilots is 15 million euro, is the first such demonstration. In conclusion, I would like to point out several ways how you can join our initiative and how we can start some cooperation. The first one is the invitation to join our stakeholder advisory forum, which is a special advisory body to which you can apply and become a project ambassador, and where you will also be involved not just to monitor more actively and through information firsthand, but also as an active interlocutor and evaluator, or particularly at the level of the regulatory framework, testing and development. So you are most welcome to apply. It's very simple to apply. You basically visit this website. You visit our website. You find the section of the stakeholder advisory forum, and you fill in a short questionnaire, and then we will evaluate your application and let you know within a couple of weeks whether the application has been approved. And of course, we like having more members at the south, so we're very happy to receive more applications to that. Another level we would really like to point out is our conference, the Hydrogen Ecosystem Conference of the North Adriatic. This is basically where it all started, and in this autumn we are going to host the conference for the 5th time in Nova Gorica and Gorizia. And as you know, this year, or as you may know, this year, Nova Gorica and Gorizia are jointly the European capital of culture. So there's even one more reason to be there. And I'd like to invite you to follow this conference as well, and find time to get to Nova Gorica and Gorizia. We are planning to dedicate an extended session on the cooperation with other hydrogen valleys this year. And certainly the last invitation that I would like to share is to take the NAV survey and to visit our website, and here it's featuring on the screen, and find a short survey where you will be able to let us know what you think about the future development and where we can have some common touch points. The deadline is by the end of this month, so that will be very much appreciated. And please register for our newsletter and continue following the NAV initiative. I hope we will be able to do many things together for the good of our united Europe and for our planet. Thank you very much, and I'll be happy to answer your questions.
Thank you. Thank you very much. I see a big advancement. I remember when this project started. Congratulations, you're going very well. You know the efforts and the bottlenecks, but it sounds wonderful. So, some questions from the other valleys. Yes, please. Present yourself here.
Paweł Petrowicz, Hydrogen Poland. I have a short question about hydrogen valleys. What do you think? What is the biggest challenge for today for hydrogen valleys? Money subsidium, or experienced stakeholders?
It's a very difficult question. The main challenge that we all share is that there is no market out there, and that there are several signals that one way or another tell us that there's still a long way to get to the market. I actually unwillingly shared, some of our challenges that may also be understood as such signals, like there's no regulatory environment. However, the valleys are, I think, a big part of the solution, because if we want to get there, to have an active hydrogen market, then we have to move several actors at the same time and involve them in an intensive exchange of information and cooperation on joint projects. So in this sense, I would say that we just need to be bold enough and be ambitious enough and accelerate the process at such a level. So to make this answer short, the more valleys, the less obstacles there will be. The real obstacle, of course, is to get to such a scale, and that's why it's important to work together and to scale this initiative. So the more valleys, the more we will be ready, and sooner we will be ready. We also have to admit that many technologies are still in a rather early phase. So we have to go through, this selection, testing, and we have to also admit that many ideas that today may look quite good or interesting will at some point be dropped or will be somehow flanked by others or overtaken by some third initiatives. So we have to be ready for such surprises, and but only a mature and scaled innovation environment can actually accelerate this process.
Yes, thank you. Other questions?
We have online question, if I can read it. What competences are you ready to transfer to other hydrogen valleys? And one more question, how can you interested stakeholders get involved?
Let's say that there are three levels of competencies that we are getting ready for transfer in the NAV project, and then there are some more specific items that we are preparing under NACHIP. When it comes to NAV, the first level, of course, are the technologies that are being matured, and of course the hydrogen produced, hopefully in the upcoming years. The second level is educational and academic programs that are being prepared, and as I said, the first one is has already been launched, has been announced, and will actually start with the first enrolled students in this spring. And the third level is early experience with the evolving regulatory framework. This is something that actually we are aware that many actors out there are expecting from us, given the fact that we are born cross-border, and we know that we have to deliver that. When it comes to NACHIP, in the follow-up project, we are preparing a replicability package, which is consisted of which is actually an acceleration program, a tailored acceleration program to scale technologies and integrate technologies in specific value chains. And so this is one more thing that will be ready in 2-year time to be demonstrated and transferred elsewhere.
Well, some more questions? We have few minutes. I would like to ask you for the test beds and the stakeholders. Those
sorry, I
companies,
didn't-
those companies, are they part of the project, and do they buy the hydrogen produced, or they are inside the project, so they have, let me say, subsidy for this hydrogen? Because they use a very small percentage of the hydrogen they would need for total decarbonization. That's normal. They have to get accustomed. However, for the future, the price should go for industry under €3. And I suppose that in the moment your price could not be less than 7, 8, €9. I don't know, maybe you
We are
could
no
tell.
different than anybody else, exactly, and your estimates are absolutely correct. So yes, all the test beds are a part of the project. They are partners of the project. And some of them will produce hydrogen, some of them will produce and use them, some of them will simply buy or transmit or store hydrogen. So these are all industrial partners that are supposed to be integrated in the logic of a hydrogen value chain. There are, for example, there has been, just to give you a very straightforward example, in Gorizia, there has been a pilot based on the subsidized hydrogen for the uptake of hydrogen buses for the urban transportation. So, and this is going to be scaled then across the whole region and also to the other side of the border to Slovenia. So this pilot is of course fully based on subsidized hydrogen, because at this point, as you say, the price is not as competitive as we would want it to have. However, we have had already demonstrations of technologies that are being piloted in the NAV and have seen significant advancements in this short period of time from the moment of application. So this is, we're talking about 2021, 22 to today. When, for example, one technology producer called Ecubes announced at the end of the last year the acceleration of the uptake of hydrogen that would actually be able to bring competitive hydrogen into the North Adriatic area at competitive prices of 3.5 and in a couple of years, and 2.5 euro in a couple of years, and hopefully less than 3 euro in just a few years more. And several other industrial partners that relate to hard to abate sector, particularly steelworks, Danieli, for example, are already examining these new possibilities. So, I mean, partners of the NAV, but also other steelworks that are not partners of the NAV. So there's quite an evolution, and I'm not saying that we have definite answers, but we see that even in this short period of time, we have increased the expectations, and we have been witnessing quite some progress. Let me also answer to the question how we motivate stakeholders. Basically, we go wherever we can, and we try to explain what we are doing, and we try to identify interest, fears, unanswered questions, and we try to motivate actors to join the hydrogen economy. We facilitate new applications for new grants, and we motivate students to join in. Particularly, the Hydrogen Ecosystem Conference is in a way the central, but not the only meeting point. But it's in this sense, it's let's say a good demonstration. One format that we developed there is the so-called intergenerational dialogue, where we have invited educational institutions, including high schools, undergraduate students, graduate, doctorate students, to debate with industry representatives and policymakers, and to take the lead in this conversation, because we are aware that this is about them. This is about the generation that is coming up. It's not so much about us. We have the responsibility to prepare for their time, and to facilitate this transition, so that when they take over, the hydrogen will already be a reality.
Thank you very much. We totally agree with you. That is one optimistic end of this presentation. Once more, thank you so much.
Thank you very much. All the best.
Bye. Now, I think that we can go for lunch. Please be back here at 2 o'clock. We shall finish a little bit earlier because we have one presentation less. So between 2 and 3 will be the final session. Well, have a pleasant lunch. Some are
still here.
So, better. Good afternoon to everybody. It's time to start our last session, which is connected again with best practices of hydrogen projects. And we're going to hear Messer in Slovakia. Slovakia very active during those 2 days. UPS and Downs of more than 30 years working with hydrogen. And the presentation will be given by Yuri Petrovich, who is head of applications and on-site technology, Messer Tatragas. Please, Yuri, the
Thank
floor
you
is
very
yours.
much. So to all of you who are still with us, have a nice afternoon. Glad to see you here. So my presentation is in 3 parts. The first part, very shortly, is a little bit of showing what we've done, who is Messer, what we've done in Slovakia in the last 30 years. Then some random thoughts which came to me partly during this summit, and some of which I'm thinking for more time, because the development in Europe is not so well, and there are some concerns which we should definitely maybe think about, and I want to just give it to you to think about also maybe, and maybe discuss after the presentation. And the third part is what we can do and what we want to do in the near future. So we've seen some pipeline projects, we've seen some big picture, and I will go maybe a little bit more into detail. So short history. I had to reduce my 40-slide presentation about the company history to 1 slide, so it's really short. Messer is quite old. It was founded in the 19th century, and Adolf Messer was the founder. And it's still a family business. The grandson of Adolf Messer, Mr. Stefan Messer, is still the main owner of the company with his 2 children. So what you can see is 1903, the first hydrogen-oxygen cutting torch was already invented by Ernst Wyss, who was actually a worker of the Griesheim company. Messer and Griesheim merged in the 60s, so therefore comes the name Messer Griesheim, which was until the early 2000 was the name of the company. In the 60s, the company expanded to Western Europe and US and Great Britain, and in the 90s, then it came to the expansion to the Eastern Europe, so even also in Poland, but also in Slovakia. Actually, Messer Tatragas was founded as a first German-Slovak joint venture ever, even earlier than Volkswagen was signed. Volkswagen came in 91. So Messer was the first German company who made a joint venture with a state-owned technical gases company in Slovakia. And in 92, Messer Slovnaft, as a joint venture between Messer and Slovnaft, the refinery in Bratislava was built, who was from the start intended also to introduce hydrogen to the Slovak market, because Slovnaft was producing a lot of hydrogen and they were actually interested to put it on the market also for other customers. So Messer Slovnaft in the past was also operating an air separation unit for Slovakia and for Slovnaft, because Slovnaft was also producing ethylene oxide, for which they needed almost 10 million cubic meters of oxygen. In the moment Slovnaft stopped this production, we had to rethink our approach, and Messer then built a nitrogen generator, a cryogenic nitrogen generator, which supplies Slovnaft with the needed nitrogen for all the inerting of a refinery, which is always needed. What you see in the picture on the right side, those are the cryogenic tanks for nitrogen, which contain 1.7 million liters of liquid nitrogen. This is a storage on site, also as a backup for Slovnaft if the generator would stop, so Slovnaft always gets its nitrogen for the inerting. Otherwise, we would have a big fire in the middle of the city in Bratislava, so we don't want that. Slovnaft provides Messer Slovnaft also with hydrogen. It's a gray hydrogen, of course. It's a classical refinery production. Slovnaft produces almost more than 10 tons per hour, so it's a completely different scale to what we are talking here about. and we are getting something like 1,000 cubic meters per hour if we want them. So if we have the need, we can take it. But it's only 3.0, so 99.9%. So we have to purify it. We have 2 purifying plants. One was built in the 90s. It was a cryogenic plant, and in last year, the second plant was started up also, which is based on the molecular sieve technology, which purifies the hydrogen up to 5.0, which is the standard we need, firstly, for our industrial customers. It's not done just because of transport or anything else. It's because most of our customers, which are working mostly in heat treatment of metals, need this purity to be able to use it. Of course, we have compressors because it's also a filling plant of us. So we fill cylinders, bundles, and hydrogen tube trailers, not only for Mesa, but actually for every competitor in the area, because, of course, carrying hydrogen is a pretty nasty business. You're carrying 20 tons of steel with 300 kilograms of hydrogen in it. So it's really ineffective, and everybody tries to get the hydrogen as close to the customers as possible. We have 2 compressors with 200 bar pressure, and Mesa Tatra Gas, which is actually the company who sells technical gases in Slovakia, has more than 230 customers for hydrogen in Slovakia. Most of them are small, some of them are bigger, and some of them are with us more than 30 years. So they are really old customers which are working with us with hydrogen. So we have a lot of installation, we have a lot of experience of transporting it, delivering it, and also to help the customers to implement it in their technologies. But as I said, until now, until early 2020, it was almost exclusively for heat treatment or other furnace atmospheres. It was never for anything else. Okay, so Jan Weiterschutz made some presentation about what's happening in Slovakia, but from our point of view, this is what we see. There are our industrial applications. There's one small transport project I will talk about later. There's the Hydrogen Valley, which was presented here also. There's 1 megawatt electrolysis and an HRS near Trnava, which hopefully starts this year, but it's built for already 5 years or something like that. Why, I will talk about also a little bit later. And there are the pipeline projects the colleagues also talked about. But that's almost it. And why? I will talk now about the problems we have, and I will show you some picture. What do you think this is? Those are 2 50 cubic meter and 1 95 cubic meter hydrogen tanks at the customer side. What's around it is a 7.2 meter high fire safety wall, which had to be built to be able to install these 3 tanks there. Yeah, so you're building a building which costs more than 100,000 euros just to install these 3 tanks. And this is what the firefighters are doing to us in Slovakia. I have another nice picture. I'm glad that the colleague is there for scale. Yeah? This is actually an 8 meter high house, which also had to be built, without a roof of course, to place a 95 cubic meter tank. So this is one of the main obstacles for hydrogen in Slovakia, actually, because if you want to, we had to stop one project in the US, still in Košice, because the firefighters demanded an anti-explosion wall around the hydrogen tank. So we couldn't build it, and we are just switching tube trailers and supply the customer with tube trailers, because this was possible. So this is one of the main obstacles we face in Slovakia for hydrogen projects. If you go to Austria, we have a customer, one of the customers is also a plant in Austria. There the vertical hydrogen tank with 95 cubic meters of volume stands near to the hole with a fence around it, that's all. Yeah. So it's not that it's everywhere like this, but it's in Slovakia, it's a very special case, and we are trying to do something about it, but it's very, very complicated. So the roadblocks, other than this, are, for example, grid problems. Bratislava Public Transport Company cannot get more electrical power to charge their battery vehicles because the grid isn't there. So it's perfect for hydrogen, of course, because we can supply that. But if they would want an electrolysis on their site, It's not possible because they wouldn't get the power for it. So those are, and in some regions of Slovakia, if the companies don't produce their own electricity, they couldn't operate. A pulp mill in northern part of Slovakia, they have to operate both their boilers to be able to supply themselves with electricity. Otherwise, the grid wouldn't be there. The electricity wouldn't be there. The grid is not there. So there's one thing. The second thing, we've had a project with a customer for electrolysis, and we wanted to do it with a hydroelectric power, which is at the edge of the company. So take a direct cable from the hydroelectric plant to the company and produce green hydrogen. We were told it's not green hydrogen. Why? Because the hydroelectric plant is older than 15 years. I said, why? No, it's like that. It's the regulation. All of the hydroelectric plants in Slovakia are older than 15 years. Most of them are from the 40s. It's on the River Vach, where all the main hydroelectric plants are. The biggest one, the Gabčíkov, is also already more than 15 years old. And as I already showed on the pictures, don't get me started on approval process and legislature. And the 1 megawatt electrolysis plant in Trnava was fighting 5 years for approvals and is now fighting through the approval process to get the startup. So this is one of the major roadblocks we face in Slovakia to really get on with hydrogen projects. So one cartoon makes it for me a little bit, in one picture says sometimes more than many words. Yeah? Europe's leading industry is at some point also creating more regulations, more standards, and more papers. And this brings me to the second part, because I was really intrigued by something which was mentioned once in this meeting, and this is the Draghi report. And I think if you didn't read it, please do. It's really important. Because what Mario Draghi is saying that we are really lagging behind US and China. If we don't do anything a different way, we get lost. Yeah? I won't read it completely, but the main is maybe the last one, that if Europe cannot become more productive, we will be forced to choose. We will not be able to become at once a leader in new technology, beacon for climate responsibility, and an independent player on the world stage. And at that point, we jeopardize the social states we have, we jeopardize the political stability we have. So this is something we really have to think about. The second thing is just an example. I don't say I agree with everything which is said here, but it also makes me think. There's a company, Hycommit, in Finland, who's producing hydrogen by splitting methane. But it's zero carbon because it's pure carbon which comes out of the process, so no CO2. Yeah? And Martti Malkamäki, who's working 20 years in decarbonizing industry, said some things which are also maybe an impulse to think about. Yeah? If you look at the US, they are working with tax credits, so you have to produce some profit, and then you get to keep it. To produce more profit, produce new technologies. So the approach maybe has to be changed. And the last one was really interesting, that GDPR is stifling project of AI programs which could help us optimize the electrolysis regulation to keep the grid stable. So you see, EU legislation, in some points, maybe nobody thought about it when the GDPR was done. But maybe we have to think about to adapt it so we can really use the AI for purposes which all of us would help. So those are some things which need to be done. And which brings me to the point. Science and not politicians should decide at the end. In 1900, almost everybody was convinced that electric cars will be the future of transportation. And then, 1908, Ford introduces Model T. It became the most sold car until Volkswagen Beetle in the 60s in the world. Why? It wasn't cheap, it wasn't clean, it wasn't good, it was just affordable and also reliable. And the second thing is also when Kennedy said in 1961 that the Americans will land on the moon until the end of the decade. The Americans had flown into space for 15 minutes. And it wasn't the politicians, it was the scientists and the researchers and the engineers who brought Neil Armstrong to the moon. So why should politicians decide which approach is best for lowering emissions? They should maybe set the goals, but they should let the industry and the science and the research to find the way. But there's also hope. What we've done in the last years, we opened the first functioning filling station for hydrogen in Slovnaft, in Mesa Slovnaft, at that time with 200 bars. And we are not the only ones. We are a very good partner in Slovakia, the Mobility and Innovation Production. We helped them to start up their hydrogen bus. So there is some data also about the bus. So it's 8 meters length. It's a composite body, so it's really light. And he has a storage of hydrogen in the back, not on the rooftop, which is normally standard for buses. And therefore also the consumption of the hydrogen for a bus is like a third of a standard value. And it has still a 60% capacity, although it is only 8 meters long, so which is normally the capacity of a 12-meter bus. So this was the first thing they did with us, also with our support, not with us, but with our support. But they didn't stop there. And it was 2 months ago, maybe, they presented this. And this is, I think, much more interesting because it's the first fully homologized fuel cell tractor truck. It's based on the Ford F-Max platform. So they're fully compatible with Ford, with all the services and everything. They really could convince, a small company from Slovakia could convince the Ford company to give them a chassis to do everything what they want with that. And they're standing fully behind them. So they have 700 bar hydrogen tanks, and they have a driving range up to 750 kilometers, which reaches actually a diesel car driving range. So we did a new 350 bar compressor and 2 new filling stations. You see more filling stations because there are also filling stations for tube trailers, but 2 new filling places. And Bratislava has 4 hydrogen buses, which they bought on subsidies, and we are filling them for the last 2 years. We are supplying the hydrogen for them. But it goes also without subsidies. And for that, Mesa founded the company Symphony, which is a joint venture of Mesa and Toyota Tsusho. And the concept of Symphony is that a fleet operator gets everything from one hand. That's why it's called one-stop shop. Because you get hydrogen-powered vehicles, production refueling infrastructure, backup supply, maintenance, operational services, and everything else which is needed. And if available and possible, also, of course, some funding, but it's not necessary. There are projects which are fully privately funded through this company. So the main thing is that the operator is actually paying only per kilometer driven. So there's no capex, and they don't have to care about any operation of any equipment because it's fully managed by the company Symphony. So this is one of the concepts which we actually do for now for 1.5 years, and we have already some promising prospects for these projects, also in Slovakia actually. So what is the workflow? Of course, we have to analyze everything that we know what the customer needs. Then, of course, the design, then we implement it, and the most important for me is the support, so the customer really has a long-term contract with the company Symphony, and we support them completely with the operation. But it's not only about buses, it's not only about other cars. It's actually, the range can be from buses, from trucks, forklifts, which we have a very good experience because we have a hydrogen supply in North Carolina for the BMW plant, where we supply daily 700 forklifts with hydrogen. So the refueling is really like standard with Mesa. And also for ports, also some hydrogen fueled vehicles or cranes or whatever is needed in a port. So that's from my side.
Thank you very much for this very interesting and analytical talk. Now the floor is open for discussion, for questions. Here we may have also discussion with Symphony, for instance. Somebody? Well,
I'm ready for discussion afterwards, no problem.
In Bulgaria, we are also working with Messer and Symphony, with the Davison. The problem is that we do not know the price on kilometer. Still.
Not yet. It has to be calculated.
Still, and that's very important because it has to be manageable.
Sure.
And the price is connected with the number of, in Bulgaria it's for buses and for city transport. So I was thinking to say something in my presentation about Symphony, but you know, I had a limited time. So thank you for doing this. So that is one option for collaboration between the countries, because above 150 buses for country are reasonable. And in another way, for one city, 30, 40 buses are also reasonable. And I think that in our countries, through the cohesion fund, there are options for subsidies. However, in Bulgaria, Messer doesn't want to produce the hydrogen. I don't know how is it in
it always
Slovakia.
depends. It always depends. We have the hydrogen now from Slovnaft, so we are talking with Slovnaft about their maybe also electrolyzer. So we already have talks about getting the green hydrogen from them to be able to supply the transport and the companies who really need it, because the subsidies for the buses are mostly connected to the consumption of green hydrogen. So if you have it in the country, we until now don't have any green hydrogen in the country, so the buses can run on grey hydrogen. That's why. Yeah.
No, I may tell you the name of the person whom you may contact for Bulgaria. That is Anton Petek, who is Messer representative.
Messer Bulgaria,
in Bulgaria. And if the other countries are interested, because here we have representatives of Poland, of
the Polish colleague is sitting here. So.
Yeah. Can we make you the contact person in the society? Yeah.
Sure, yeah.
Okay.
If you need anything, contact me and I will forward it to the respective country, because Messer is
Let us try to unite around the idea of Symphony and facilitate the utilization of hydrogen in bus transport, because the municipalities, they do not have the capacity, even if they have the money, to support the production of hydrogen, the maintenance of the buses. All this is difficult for them. In the small towns, they do not know English. The communications is difficult, and that is a way when the price goes down, and it goes down if we are more interested in this, then that's one option for city transport in hydrogen.
Yeah, but I have to mention also, we have one of the projects we have in Slovakia is actually not with buses. One of them is actually for the new trucks, which I presented, because we have some container moving company also in Slovakia, which are already talking about taking some 10 of these trucks, because also they have to decarbonize their fleets. And they already tried battery trucks, and now they will be testing this hydrogen truck for the next month. So they're really go into it. And of course, that's the main point, that a city or city transport company
There are
or
money
regional
for
transport
this
company
in our countries for
cannot
the,
manage this
yeah.
because they don't know how to do it. We
Yeah.
have 35 years experience with hydrogen, so we can do this. It's not
Yeah.
a problem for us to install everything and manage it. It's our on-site concept actually, where we operate generators for gases, where we always operate the equipment for the customer. He gets just the gas. Here, the customer gets just the bus, properly filled up, properly serviced, and he provides just the driver. And everything else is done by us. That's the main thinking about behind it. Yeah. And the main message is also money is there. That's not a problem. If there is possibility to sign a long-term contract, the money is there. It's not a problem. Even privately, it's private equity. It's no EU funding or whatever.
Well, during the roadshow in every of our countries, the drivers started running this bus after 1 hour education. So that's not the problem. Yeah. I'm stressing on buses because it's easier to find money, national money for decarbonization of the air in the big cities and money for buses.
There was, I think, a question?
Yeah.
Yeah, I have a microphone, if so, sorry. Yeah, can I first one or you? Okay, ladies first.
Oh, okay, you want me to go first? My name's Emma. I'm curious about, you said the fuel cell electric vehicle trucks were at 700 bar. What considerations went into choosing that pressure and what advantages does that pressure have?
Driving
over
range.
others?
Simple.
Range.
Driving range. They really wanted to match a diesel truck. So they have the technology, they know, they found the proper supplier for the tanks, which is very important that you have all the approvals and everything. And the driving range was the main driving factor for that. And you saw you get even additional 120 kilometers with the traction battery, which is already also there. So, and you can charge it and fill it with hydrogen at one time. It has a charging point, so you can charge the battery full and at the same time also fill up the truck with hydrogen. They have the same feature also with the bus. So you can charge it and fill it up at the same time. So it really shortens the turnover.
Thanks.
Yeah, sorry, I wasn't in the beginning of your presentation. Very nice one. 3 questions. First one, I saw dispensers. They seem so simple.
Yes.
What does it mean that you have very simple rules that you can make such simple dispensers? As we see today, they are looking very complicated and so on.
This is not a standard hydrogen refueling station because this is situated at our filling plant. So there are zones there, and it's not a self-service thing. This is really just a refueling point where we normally fill the tube trailers. And we made just a connection to the main pipeline coming from the big compressors we have there, hydrogen compressors, so we can also fill up other vehicles. So we purchased the connectors to be able to connect to the vehicles, and we made a simple panel which just puts through the hydrogen from the main line coming from the hydrogen compressors to the vehicle. So it's a different kind of equipment. It's not a standard HRS. Yeah, it's not operated on high pressure buffer and whatever. It's just connected to the line, and the compressors have to be working. But we almost always have some tube trailers for the filling there, so it's no problem. It's always operated. And we fill up every day. We fill up the Bratislava buses. They're coming every day.
Okay, and another one question: buses. Do you use them for public service?
Yes, these 4 buses are from the public transport company of Bratislava. They bought them. This was a separate project.
And what the price for the ticket is, if to compare a normal bus and this one, hydrogen-driven?
The ticket is the same. Nobody cares.
So
they have a lot of electric vehicles.
Somebody
it was founded by
cover.
the EU. These 4 buses were founded by the EU partly. I don't know, 50% or something like that, and the rest was financed by the city.
Okay.
They made it as a pilot project, and they just got some funds from the EU for these 4 buses. It was not a symphony project. 4 buses would be too small. A fleet of 20 is the minimum. I would say 30 or 40 is really like you said. It's just the normal size of a fleet where it makes sense.
Thank you.
And you do not use green hydrogen, you use?
We still use gray hydrogen because we don't have any green. So we are waiting for the Trnava project because they will be producing something like 200 kilo per day. And we are in negotiations with them that we will purchase it. And of course, the Hydrogen Valley in Košice is a second project where we are talking about being actually the customer of them for the green hydrogen.
I'm wondering about the restrictions for green hydrogen, because if we use hydrogen, no matter, for instance, electrolysis from the grid, we decrease the CO2 emissions. On the road, the grid uses about 30% of renewable. So what is better, to be so strict for totally green and not to have it because it's difficult, or to decrease the restrictions and use electricity, which is 30% green, and have hydrogen developed like technologies, like acceptance? Did somebody calculate the advantages of the second approach? And my second question to the audience is, when we're talking for battery electric buses, do you know somebody to insist on green electricity? I don't know. Why should there be double standard for hydrogen, restrictions, and it is in the very beginning when you have to support it, and on the other side, electric buses that use normal electricity? If somebody can answer, so I'm sorry, we went into discussion, but if somebody can answer my questions, I will be thankful.
I have to just say that you are completely actually along with what I said, that we should first develop the technology and implement it, then start to restrict the usage. Because we also said, okay, we could wait for green hydrogen with these filling points, but we said, no, we start with gray, so we get a feeling how it works, how the industry works, what is on the market, what can be done. And then we gradually can go to the decarbonizing steps, but we cannot start with that because we restrict ourselves too much. As you said, it's too much restriction. Who cared about electricity, energy mix when the electric cars started in the cities? Nobody. I mean, half or more, maybe more households don't have green energy and they charge their cars at home feeling like they are very green. So, yeah, especially in lands where the carbon footprint of the energy grid is much higher than normally. Yeah. So, okay, I agree completely.
I'll tell you something. When that was a discussion, one of the motivations was that Norway will have 90% green electricity, and it will be beneficial for Norway and not for the other countries, but that's exception. Let's give them the benefits. But for the others, why should you punish them? Because somebody might have benefit. I don't know if Hydrogen Europe representatives is here. Maybe
not anymore.
we could put him this question so that it could go to Jorgo. I know that Jorgo will support us, but to the politicians, that we have to decrease the restrictions if we want to give green light to something which has to develop. Okay, thank you very much.
Thank you also for the discussion.
For this discussion. And we are going to the last talk, which is also very interesting because it answers in one hot niche. It is connected with contacting practices, hydrogen sales and purchase agreement, best contracting practices, and as given by one doctoral student, Agnieszka Gorka, University of Gdańsk.
Thank you very much for your perseverance until the end of the event. My name is Agnieszka. I'm a doctoral student at the University of Gdańsk, where I prepare my doctoral thesis about hydrogen regulation in Poland and European Union. I am a lawyer. And today, at the beginning of my presentation, I present the type of contracts that are regulated in Polish law. Then we will focus only the hydrogen purchase and sale agreements, including elements of its supply, excluding hydrogen networks. I will describe the most important contractual terms to be covered in the contract. As a reminder, there are several types of hydrogen and derivatives like ammonia, methanol. I think I don't have to define this definition, and I remember that sometimes we have a problem with renewable hydrogen. Hydrogen is defined as hydrogen produced by electrolysis of water using electricity from renewable sources, as well as produced by biogas reforming or biotechnical conversion of biomass, provided that the requirements for sensitivity are satisfied. Next, the diagram shows the types of contract in energy law in Poland, but these are contracts found in every European Union country. First, we have a hydrogen transmission service contract, hydrogen networks. Next, hydrogen storage service contract, and purchase and sale agreement. All of absence of fundamental elements necessary to characterize the contract may lead to invalidity, and we should remember about these obligatory elements in each agreement. In this slide, you have hydrogen transmission service contract. They have obligatory elements. Next, storage service contract, and then purchase and sale agreement, obligatory elements. You can see on this slide all the elements of agreement and purchase contract. Some of these elements might be crucial for hydrogen transactions. The contract structure that I present based on a framework hydrogen agreement carried by HINCO, published in January this year. The contract stipulates that HINCO will purchase green hydrogen or derivatives from producer through hydrogen purchase agreements and sell them to customers through hydrogen sale agreements. The individual next slides show the fragment of the contractual terms and conditions. First, we have a slide about framework agreement and individual agreements. A popular solution in contract is to enter into framework agreements which present previous on liability, measure forces, or termination. The individual contract is the integral part of framework agreement. Such agreement contains information of hydrogen supplied period, the price of hydrogen, and the provision of this framework agreement might be superseded and supplement those on the individual agreements for the term the individual agreements in the force. In case a conflict between the provisions of the both agreements, the individual agreements shall prevail. Next slide should delivery schedule. Customers accept a shortfall of up to, and we in this empty place we can put number of day per batch of products as nevertheless being compliant with delivery obligation, provide however that only that amount of product actually delivered shall be invoiced and paid. The delivery schedule is determined in an individual agreement. In such a contract, special attention should be paid to a provision and allows from the acceptance of a hydrogen shortfall. In the case of RFNBO hydrogen, which depends on energy sources as solar and wind power, it's very important to introduce the possible of individual adjustments in delivery service, delivery schedules, such extension of deadlines, partial delivery, or additional delivery attempts. The contract requires the specification of the hydrogen delivery point. For example, a flank of tank storage on pineapple infrastructure, and it's very important terms in contract, product equality and compliance, because in the case RFNBO and low carbon hydrogen, we should about these terms. The product must comply with the technical specification of the product we are agreed in the individual contract. Prior the delivery supplied shall have the seller demonstrate compliance of the product with the technical product specifications by having each shipment of product, which may include batches or product to be delivered to other customers, tested in the place of delivery. Upon delivery of the product, supplier will provide customer with the hydrogen global declaration, sustainability as set forth in annex prepared by seller. And you can see this how this declaration, and yeah, we have information about energy supplies, information about product and the carbon, and yeah, okay. No. Yeah, and supplier will provide customer with information and documents reasonably required to meet customers' obligation. Present to Article 31 Directive RED 2, the article points to member states shall require the relevant economic operators to enter in a timely manner accurate date into the union debates on the transactions made by the sensibility characteristics of the fuel subject to those transactions, including the life cycle greenhouse gas emissions, starting from their point of product at the moment they are placed on the market in the European Union. And is next slide about non-conforming products. It's useful to remember to regulate product defects. We have an example of terms that we use in this contract. And next, we have liability, and that's the next very important terms. And I think the most interesting for me is force measure. Every contract have a standard example of force measure. There are also we can have a short list of, about force measure, flood, earthquake, natural disaster, but there are also specific examples of situations that might significantly affect the ability to perform a contract, like fire, explosion, or accident, or damage to infrastructure required to delivery of a product. And lack of infrastructure, lack of infrastructure at the place of delivery, mechanical breakdowns, seller being unable to procure access to storage. And for me, the most controversial example of force measure is adverse weather conditions. The RFMBO hydrogen contract is very important. You will ask why. In order the force measure to be considered to exist, the following cumulative condition must be met. And that's these terms and condition that we have must be met. Could not a responsibility by foreseen by the part at the time when entered into this framework agreement or individual agreement, or when the representative delivery date is determined, and cannot responsible be avoided or overcome by the party. The manufacturer is award of the outside the products will be unstable due to the water or the technical rules of operation of the electrolyzers. There is a preventive solution in the form of hydrogen storage by producers. And in the case a major force event at the parties shall discuss in good fight whether the contractual obligation affected by the force measure event can be fulfilled at a later time, and whether to suspend the running certain deadlines such as deadlines for failure of the first and second delivery attempt. In the future, or daily is due to lack of infrastructure at the place of delivery, which makes delivery our product impossible. Either party may terminate the individual contract agreements. And thank you very much for your attention. If you have any question, I will try to answer them.
Well, thank you for this presentation, which is finalization of all the efforts in production, in transportation, and so on. So in the end, we are expected to do also this. Is that somebody questions?
Yeah, I have one question. For us technical people, it's always difficult to understand lawyers. But anyway, I will try to formulate a question. So, is it possible to take simple LNG network, sales, storage contract, frame of that contract and to apply to hydrogen? Or it is something different? I understand the annexes, amendments, they should be different, technical things different. But is it necessary to have special contracting to LNG?
Okay. I think that this contract is based on a gas agreement, and I think that have a special, very important terms and conditions, like the measure force that about the weather condition, and I think that the quality, special quality, and the declaration of this technical specified is, I think that is new in this agreement that we don't have developed in gas agreement.
Other questions? I want to ask, is that a Polish declaration or it is
a German? German, but
is it a German? It is accepted on European level?
Yes, and this standard contract that created by German, and that's the terms and condition is very standard in each agreement in European Union states.
And is it applicable in Germany, or it is just a document which is proposed, or do they use it in the moment?
We can use at the moment, and it's used in German.
No, do they use it? We can, but do they use it? Do you know, or do you have information?
No, I don't have information.
They are using this document?
I don't have information.
Yeah.
And at this time.
Because there are many requirements about purities and so on, which have to pass through special authorized laboratories that would certify that the quality is exactly this. And then if you are not on the transportation, another certification that the quality is not the same. So there are many additional structures that should follow the implementation of this contract. So it will be interesting if we could know for the future if it is already applicable somewhere, or it is just a proposal for the future.
And I present all the structure of a contract, and I choose the most important, most problem contractual terms, and I think that disputes governing law, it's very standard in contract, and we don't have a problem with these terms in contract. But I think the most dispute is when we have product quality, liability, force measure, and we should good create that regulation, and I think that in the future some contracts show where is a problem.
Yeah, for the future, maybe the natural gas follows similar procedures. Yeah.
Maybe just a small note on this. We are making such contracts for more than 30 years, and there are standard documents which are normally supplied to the customer. So you have some product specification, which is stated what the quality is and so on. Then you have a safety card, which is always also provided, so the customer knows what to do in case of any problems. And if the customer wants, then of course we can also supply a product analysis with a certificate. It's a paid service, it's normally not provided for standard customers if it's not a specialty thing. So this is standard for us, and this is standard also contract framework which we are working with on daily basis. So there is nothing has to be invented anew. When I saw the product specification, it was quite very detailed, I have to say.
Yeah.
It looks to me a little bit too much, actually, because
For
I don't know
this
if
stage.
some of the information of it are not proprietary for the producers of the hydrogen.
Yeah.
Nobody wants to tell you exactly how much and when and what. If it's not a medical product, there is no charging of hydrogen product.
Yeah, that was when I saw the table with the, yes, that is the standard procedure, but we didn't come to this stage as mass transportation, so we have to get accustomed, we have to know. So thank you very much for this final presentation.
Thank you very much.
It was useful to know this also. So with this, our 2 days promenade in the different pathways of hydrogen production and transportation and utilization just to an end, like every conference. I think that it was very fruitful, very dynamic. I'm sure that everybody will go out from here with more knowledge, with more questions, with more ideas. And we close this conference, but in the same moment we open a new pathway for realization of those ideas which you created here. I think that we understood that communication and integration in common efforts is necessary, especially for some parts of the hydrogen deployment. So I would like to wish you, when you come on the next edition of this conference, to start with new ideas based on this, which are going to develop between today and the day of the next conference. So have a safety trip back home and good luck in your activities. Thank you for being so active here and for participating, and I hope we'll soon see again. Thank you.
Ladies and gentlemen, the last words from me. On the behalf of Litvan Group, I would like to thank all the speakers for their commitment and interesting presentations. I would like to also thank all the participants for coming and joining this discussion, and for all people who joined us online. I would like to thank both our chairman, Jakub Kupecký, and Daria Vladikova for their guidance through our conference. We're looking forward to receiving your feedback on the event through the evaluation form, email, or just give us a call. If you filled out the evaluation forms, please hand it to me or my colleagues. We are looking forward to your feedback. It was a great pleasure to be here with you. We are looking forward to see you on the another Litvan Group event. And last but not least, I'm looking for 2 to 3 volunteers who will be willing to give us 1-minute feedback for our interview. And for the rest of you, safe travels home. Thank you so much.